Hello, hello, my dear friends. I hope that my voice and the video is clear. Good evening, everyone. Good evening. I hope my audio and the video is clear. Good evening, everyone. Good evening. Good evening, everyone. I hope my audio and the video is clear. Good evening, everyone. Good evening. Okay, fine. Hi, everyone. Hi. Hello. Now, my dear friends, today we are going to start the very important chapter of our JEE as well as NEET. Now, today I am thinking you to take, or I want to finish the entire chapter. I don't know when it will be happen. It may take 11 or it may take 12 or it may take 1 also. Okay, but I will finish today. How much time you are able to in the class you can be, and the rest you can see after completion of this live also it will be there. Okay, but I too don't know when it will be complete. Clear? Be in a class, but until the time you are in the class, be effective. And I was giving my personal time to make your academics very clear, and this is a very important chapter and a very basic chapter also, and it is very important. We may get 2 questions in the JEE as well as the NEET also. Done? Clear? Now let's start our chapter. Now my dear friends, whenever I was asking the question, don't be in hurry. Okay, and don't search in any Google or any other source. Try to do it by your own, especially the calculation part only. It will make you difficult for you to give the exact answer, right? Now I hope it is clear for everyone. Now let's start the lecture. Now, before going to the thermodynamics, now what is the meaning of the thermodynamics? Thermodynamics. In the thermodynamics, mainly we are going to deal with the gases called the ideal gas. Okay? Everyone, good evening. Everyone, hello and hi. Now I was starting the class. Now try to be focused to the class, right? Now first, what is the definition of the thermodynamics? The study of flow of heat or any other type of energy, into or out of the system during physical or chemical transformation. Is called thermodynamics. Okay, now this is a basic definition, but the very key point you have to remember in this basic definition is the term energy. This word will play a very crucial role in understanding the terminology of the question. If I was using the word energy in the thermodynamics, this word will be either, this energy will be exchanged either through the heat or either through the work, either through the heat or the work. This is the one key point you have to remember. And the next key point you have to remember in the thermodynamics is mainly we are going to deal with the gas, that is ideal gas. Now we know the ideal gas equation, right? PV is equal to nRT. PV is equal to nRT. Until unless they mention the gas is real in the question, done. But mainly we will take the gases called the ideal gas, right? Now before going to start the chapter, here we have to use some basic terms which we are going to use in our entire chapter. Now what are the basic terms that we are going to use in our thermodynamics? Can anyone? What are the basic terms that we are going to use in our thermodynamics? What are the basic terms that we are going to use in our thermodynamics? Terms used in TD means thermodynamics, don't get confused. Terms used in TD. What are the terms that we are going to use in our? Now one is system, one is a system and another is a surrounding and another is a boundary, right? Right. First is a system. Now what is the definition of the system? Now, first the definition of the system is any portion of the universe, any portion of the universe which is under our observation, is known as a system, right? Now here first I will explain generally, then after that I will explain on the basis of the thermodynamic point of view. Let's suppose we'll take the one classroom, right? Now this is the one blackboard and we are the students sitting here, right? Now here for the faculty, this students and this classroom is under his control, so this is a system to him. Now this classroom is present in one universe, right? Remaining portion of the universe we call it as a what? Surrounding. The portion which is under our observation, this classroom is under our observation, right? So this classroom is our system. Now remaining portion of this classroom entirely we call it as a surrounding. Now we know, and this system and this surrounding, this classroom and the outside of the classroom is surrounded by the wall, right? Clear? Now that we call it as a boundary. Done? Now this is general example to make you to understand. If I want to make you to understand on the basis of the thermodynamic point of view, in the thermodynamic point of view, what we are going to see? We are going to deal with the gaseous, right? So I was taking the one container and in this one gaseous reaction it is going on, okay? One gaseous reaction it is undergoing. Now this gaseous reaction is under my control, right? Now this gaseous reaction is our system. This gaseous reaction is happening in one universe. Other portion is called as a surrounding. Clear? Now this gaseous reaction happening and surrounding, which are separated, boundary has been separated, right? Clear? Now these are the basic terms we have to use or we are going to use in our entire thermodynamics. This is a system and the next one is a surrounding. Now what is the meaning of the surrounding? Other than the remaining portion of the universe, remaining portion of the universe. Remaining portion of the universe is called as a surrounding. Now here the one key point you have to remember, that is system plus surrounding. System plus surrounding is equal to, can anyone? System plus surrounding is equal to universe. This is a one key point you have to remember. System plus surrounding is equal to universe. Next. And the next one, the third we are going to see, that is boundary. Yes. Good. Now the third one we are having, that is a boundary. Now here the boundary may be the real or imaginary. This is the one key point you have to remember. Clear? Now real or imaginary, real or imaginary, which separates, real or imaginary, which separates system and surrounding. Clear? Now what is the meaning of boundary? May be the real or imaginary. Let's suppose just now we have taken the one example, right? What is the one example we have taken? Classroom is the one example we have taken, right? Now this is a classroom. In this classroom, now this is a surrounding. Now this is a classroom and the remaining portion of the classroom is called as a surrounding. Now here this classroom and the surrounding has been separated with the real boundary or imaginary boundary. Now this boundary of our classroom wall is separated, or this is a real boundary or imaginary boundary. This classroom boundary is a real boundary or imaginary boundary. Good. Now whatever may be the boundary, this classroom and the surrounding it has separated, this we call it as a real boundary. Done? Real boundary. Now let's suppose I was taking one vessel I will take. Here also one type of the imaginary boundary, real or imaginary, one imaginary type of the boundary is also acting on it. So boundary may be the real or imaginary. Here in this condition one imaginary type of the boundary it is acting. Now in this case one real type of the boundary it is acting. Here boundaries are the real or imaginary which separate the, which separates system and surrounding is called as a boundary. Now here we are having the two types of the boundaries, or we can say it as a wall. Clear? We are having two types of the boundary. Two types of the boundaries. Now what are the two types of the boundaries we are having? First one, diathermic wall. Now what is the meaning of the diathermic wall? Can anyone? Now diathermic wall. What is the meaning of the diathermic wall? What is the meaning of diathermic wall? What is a diathermic wall? Diathermic means which allows the exchange of heat, which allows the exchange of the heat. Now second one, adiabatic wall. Next one is a adiabatic wall. Now what is the meaning of the adiabatic wall? Which does not allow exchange of heat. So my dear friends, they will ask you one statement based question. They will ask you one beautiful statement based question. They will ask you What is the beautiful statement based question they may ask? Will the diathermic wall exchange the energy? Is it true or false? Diathermic wall will exchange the energy. It is true or false? It is true or false? I hope my question is clear for you. I hope the question is clear for you. Okay, I will write. Better it will be clear for you. Diathermic wall allows the energy. True or false? Now, actually, one very key point I was explained here in the starting. What is a very key point I was explained? Now, energy may be exchanged either through the heat or either through the work. In the thermodynamics, either the energy may be exchanged either through the heat or either through the work. Now, when I was written the diathermic wall, I was written only the heat, but I was not written the work. See, diathermic wall which allows the exchange of heat only, but it has not allowed the exchange of the work. Here work is not happening, only the heat it is happening, only the heat exchange only it is happening, but not the work. My dear friends, you have to be very careful here. Work to be done in thermodynamics, wall should be a movable wall. It should, or movable piston. Wall should be a movable piston. It should be there. Now you can see here in this case, this wall is real wall or imaginary wall. Now this is a real wall. Real wall we cannot be moved. In this, when the real wall, when it is not moving, work cannot be done. Why? Here, if the movable piston, if it is not there, work cannot be done. Here this is a real wall. In this real wall, only the heat can be exchanged. But in the thermodynamics, this is a one key point you have to remember. Work to be done in the thermodynamics, the wall should be movable. Wall should be a movable piston. Then only, if the movable piston of these walls are having the movable piston, then only the work can be done. So either that energy can be either exchanged through the work. But here in the diathermic wall, whatever may be the wall we have taken, that is a rigid wall. In the rigid wall, work will not be done. Why? Can anyone say me? Why in the rigid container work cannot be done? I mean, energy is not exchanging through the work. Why? Because in the rigid container, what is constant? In the diathermic, volume is constant. If the volume is constant, why the work will be happen? Work will not be happen, right? So in the diathermic wall, energy can be, it allows the energy, but only through heat. Only through heat if they have given, that is true. Only through the heat only the diathermic wall can exchange the energy, only through the heat, not through the work. You have to be very careful with this statement based questions. In the statement based question, they may ask, diathermic wall allows the energy only through the heat or only through the work, or it can be allows through both. If that type of the question they have given, you have to be very careful with this statement only through the heat, because in the rigid container volume is constant. Volume is constant means work done will be the zero. Why it is zero? With the help of the with a beautiful derivation I will explain. Okay, right. Next, now you got to know that we are having the two types of the wall, that is one is diathermic wall and one is a adiabatic wall. Next, depending upon the nature of the boundary, systems are of the three types. What are the systems? What are the system? May I know? Depending upon the nature of boundary, depending upon nature of boundary, systems are of three types. What are the three types of the system? Now what are the three types of the system? One is open system, one is closed system, and one is a isolated system. Right. First one is a open system. First one is a open system. My dear friends, you have to be very careful in the open system. What is the open system? Open system means both energy. Here I was saying the energy. Now you see, here I was saying the energy. Both the energy and matter. Both the energy and the matter is exchanged between system and surrounding. Clear? Now, example, if I was taking the one vessel and here it is a liquid, right? If I was heating this one, now this is our system. From here to here, what it is exchanging? Heat it is exchanging. Now, before when I was supplying the heat, let's suppose this water we are having the 10 ml. When the heat is supplied to this system, now the same 10 ml of the water will be there? No, some amount or some matter of the liquid will be converted into the gas. Means when it has converted into the gas matter, it is exchanging between the system and surrounding, right? Both the energy and the matter is exchanging between the system and surrounding is known as the open system. From here to here, energy is exchanging through the heat. Now matter is exchanging between the system and surrounding. This is the example of open system. Next one. Second one, closed system. Now what is the meaning of the closed system? Means which does not allow the exchange of matter. Means only the energy can be exchanged but not the matter. Energy exchange but not the matter. Example, here you can see. Now here if I closed the container, now if I was heating, now from here to here the heat is exchanging but matter it is not allowing to go out from the system. So this is a closed system. Now third one. Next one, the third one is a isolated system. Now what is the meaning of the isolated system? Which does not allow the exchange of the heat and the matter. Now what is the which does not allow the exchange of the heat and the matter? The same thing for our same system. This is closed. Now what I was doing, I was thermally insulating this one. When I was thermally insulating this one, now it will not allow the exchange of heat to flow into the system. Here to here heat will not be transferred. Now here to here the matter also will not be exchanged. Means what is the meaning of the isolated system? Both energy and matter. Both energy and matter is not exchanged. Can anyone say me the perfect, can anyone say me the example for the isolated system? Can anyone say me the example for the isolated system? That is a thermos flask. Thermos flask is the one example for our isolated system, but we cannot say it is a perfect isolated system. But we cannot say it as a perfect isolated system. But as of now, just we can consider. But it is not the perfect isolated system, because there is no any perfect isolated system. But we can consider entire system as a universe. If you consider the universe, entire universe, if we consider that universe will be the perfect isolated system. In the second law of thermodynamics, when it started, I will explain. Next one, we are having the depending upon the number of phases, systems are of two types. One is homogeneous. What is the meaning of the homogeneous? What is the meaning of homogeneous system? Homogeneous system means system with only one phase. System with same phase. Example, PCl5 gas gives rise to PCl3 gas plus Cl2 gas. Now this is a system with only one phase, is called as a homogeneous system. And second one, we are having the heterogeneous system. Now, what is the meaning of the heterogeneous system? Means system with a different phase. Example, CaCO3 sodium carbonate when we have heated. Now CaO solid plus CO2 gas. Right? Now two different phases we are having, right? Now that one we call it as a heterogeneous phase. Next one, very important one we are going to study, that is thermodynamic property. Thermodynamic properties. Now, what is the meaning of the thermodynamic properties? Here we are having the two types of the thermodynamic property. Now, what are the thermodynamic properties? I will explain very clearly. Now, listen. Let's suppose I was taking the one rigid container, and here we are going to deal with the gaseous, ideal gaseous, and here we are going to deal with the ideal gases. Right. Now, what are the thermodynamic parameters I was to keep? Or what are the thermodynamic parameters I was to keep to start this reaction? One is a volume, one is a pressure, one is a temperature, and one will be the number of moles. We know, according to the Avogadro's law, V is directly proportional to the N. Done? Right. If it is a closed container, this is a rigid container. If it is a rigid container, V will be constant. Done? Now, here this is a gas 1. Now this is a gas, let's take this is a gas 2. Done? Now, volume is 10 ml will take. Pressure is 1 atm will take. Temperature 300 Kelvin will take. And the number of moles will also 10 moles will take. Done? Before, what I was doing, if I did a partition to this container, and this is a closed container only. For this closed container, if I did a partition, best example, now this is our classroom. Now here we are having the students. Clear? Now this is our blackboard. Now if I did a partition to this class, let's suppose 50 students are there. Then after doing the partition, what it will happen? It will become 25 students here and 25 students will be here, right? Now, same thing when I did a partition. Now, volume, what it will happen? Volume, before it is a 10 ml, right? Now it will become by 2, right? By 2 means this one will become 5 ml, this one will become 5 ml, right? Next. Now, after doing the partition, whatever may be the pressure it is having for the gas 1 and the gas 2 will have same pressure or different pressure. After doing the partition, gas 1 and the gas 2 will have same pressure or different pressure. That you have to say. Now, gas will have the same pressure because this is a closed container. In this closed container only we have did the partition, right? So, gas 1 and the gas 2 will have the same pressure. And gas 1 and the gas 2 will have same temperature or different temperature. Same temperature or different temperature. Gas 1 and the gas 2 will have same temperature or different temperature. Gas 1 and the gas 2 will also have the same temperature only. But what it will be changed, number of moles and the volume will be changed. If the volume is changing, number of moles obviously it will be changed because V is directly proportional to the N according to the Avogadro's law. Means the parameters which has not changed, that parameters will be comes under the, or that properties will comes under the intensive property. Now the properties which are changing, that properties will comes under the, which one? Extensive property. So what are the thermodynamic properties we are having? Now, the physical quantity, the physical quantities whose values define a system completely. Whose values define a system completely. Clear? Now here we are having the two types. One is a extensive and second one is a intensive. One is a extensive property and one is a intensive property. Now first we are going to study about the extensive property. Now the very important point for the extensive property, you have to remember that it is a mass dependent property. If the mass change, this property also will be changed. Mass dependent property. Clear? Next. The next property is extensive property. Extensive can be additive and divisible in nature. Extensive property can be add and we can divide, right? Next. Very key point you have to remember, that is a note. Ratio of extensive property by intensive property. Ratio of extensive property by intensive property will give you the, which one? Extensive property. This is the one key point you have to remember. Sir, how sir? Now with the example I will explain very clearly. Now we'll see what are the examples that it will comes under the extensive property. Now what are the example it will comes under the extensive property? Now I will explain. Wait, let me just. Now, can anyone see me the one example for the which will comes under the extensive property? Example that it will come from comes under the extensive property. Example that will comes under the extensive property other than mass, length, number of moles. Okay, number of moles. Good. Number of moles other than mass, length, volume, area, number of moles. Other than this, Gibbs free energy. Next, Gibbs free energy. Next, any other? Any other? Internal energy, good. Heat capacity, good. We are having the mass, area, length, number of moles, volume. Next, this is internal energy, Gibbs free energy, enthalpy, good, force, good, force, good. Next, still we are having heat capacity. This is a very key point actually. Heat capacity is a volume, force, heat capacity. Next, some other also are there. Mass done. Mass, area, length, number of moles, volume, internal energy, Gibbs free energy, enthalpy, entropy also. Good Subhana, good. Specific resistance, right. Specific resistance and absorbance. Clear? Now these are the some examples that we are having for the which one? Specific resistance, area changes. Specific resistance, area, length changes means specific resistance also will change, right? If area and the mass, it will be different, right? Then rho L by S. Okay. Now these are the examples for the specific resistance, extensive property. Now second property we are having intensive property. Next one we are having the intensive property. Now examples for the intensive property are mass independent properties. Mass independent properties. Mass independent properties will comes under the intensive property, and the very key point you have to remember that it is ratio of two extensive property. Ratio of two extensive property will give intensive property. Ratio of two extensive property will give you the intensive property. Example, if you take the pressure, just now we know pressure, it is not changing, even though we have changed the mass also, number of moles we have changed also, pressure it is not changing, means it is not depending upon the mass. Example, what is the pressure formula? Force by area, right? Force will comes under the extensive, area will comes under the extensive. Done. Next any other? Density formula. What is the density formula? Mass by volume. Mass will be the extensive, volume is extensive, so density will comes under the intensive. Next, concentration. Any concentration term you may take, any concentration term. Concentration also will comes under the intensity. How? If you take the molarity, N by V, molarity is the N by V, number of moles is the extensive and volume is the extensive. So here you may get it out, sir, the ratio of extensive property and intensive property will be the extensive. Example, sir, example is number of moles. Number of moles is example for this one. Number of moles is the example for this one. How? If you take the number of moles formula, N is equal to mass by molecular weight, right? Now molecular weight of the given substance is fixed. If you take the H2O, if you take it in the normal water, or if you take it in the sea, or if you take it in the ocean, H2O molecular weight will be fixed. So it is not depending, it is not changing with the mass. So it is fixed property, intensive. Molecular weights are intensive. Mass is extensive, right? Ratio of extensive property by intensive property will give you the what? Extensive property. Next, here also you can see sometimes they make you confuse. What? Volume, molarity, or mass by density. Mass by density will comes under the extensive property or intensive property. They will ask you. You have to be very careful. Here mass and it is a density. Density is a intensive, mass is extensive, and it will become the volume, right? Volume is extensive. This type of the questions also they may ask to make you confused. So you have to be very careful. Done. Next other examples we are having for the intensive property, that is a molar volume. Next, molar heat capacity. Next, specific heat capacity. So my dear friends, you have to be very careful that heat capacity and the specific heat capacity both are different. Heat capacity. Next, temperature. Next, vapor pressure. Next, boiling point. Clear? Next, rate constant. Next is a rate constant K. Next is a universal gas constant R. Next is a viscosity. Next is a viscosity. Next is a surface tension. Next is a refractive index. Now these are the some examples that we are having for the extensive property and the intensive property. Now what are the key points you have to remember? Ratio of extensive by intensive. Now extensive properties are additive and divisible in nature, and here is the one key point that you have to remember. Ratio of two extensive property will give you the intensive property, and these are the examples. Now I will give you the one beautiful question which it has came in our JEE Mains 2025. In the 2025 itself, one beautiful question it has came from this concept. Now I will write. Be careful. Don't be in a hurry to give the answer. Try to see the logic behind the question they are asking. Wait, let me write the question. Don't be in a hurry to give the answer. See the logic, how they are asking the questions from this extensive property and the intensive property. Now the question is asking which of the following properties will change when system containing solution 1 will become solution 2. Okay, when the solution 1 has become solution 2, now which of the following properties of the system will be changed is asking. So solution 1, for the solution 1, 10 mole of solute X plus 10 liter of water. This is a solution 1. From this solution 1, when it has converted into solution 2, that is 1 liter of solution 1 plus 1 mole of solute X solute X plus 1 liter of H2O. This is solution 2. Now which of the following parameter will be changed? Option A, molar heat capacity. This is molar heat capacity. Now option B, density. Now option C, concentration. Option D, Gibbs free energy. Option D, Gibbs free energy. Now what is the answer? Now you have to say. Same. This is April 3, 2025 shift. April 3, 2025 JEE mains question. Same concept. Extensive property, intensive property concept question only. Simple. Simple. By seeing itself we can say. What is saying? Which of the following property will change when the system contain solution 1 will become solution 2? Will change is asking. Molar heat capacity is fixed property. One thing you have to remember, any property it is fixed, which does not change if the mass also change or volume also change. If that parameter, if it is not changing, that properties will comes under the intensive property. So molar heat capacity will not change. Density will not change. Concentration will not change. Only the Gibbs free energy will be depend upon the mass. Only the Gibbs free energy will be changed. Okay. I will say with the general example. Now you can see 10 moles of solute X present in 10 liter of H2O. So if I want to calculate the concentration formula, number of moles by volume. Number of moles by volume, right? So number of moles is 10 and volume is 10. So concentration is 1 in the solution 1. When it has converted into the solution 2, concentration 1 liter of solution, volume is 1 and 1 mole of solute. Concentration how much? 1 by 1. It will be 1. Concentration is 1. Here also density is same. Moles by liter. If you convert into the volume, that also it will get the mass set 10 only. Then density also will say. Molar heat capacity it is fixed for the, let's suppose for the 10 moles molar heat capacity is 10. Then for the 1 molar heat capacity also 1 only. So all the 3 parameters are fixed. Only it will be changing the Gibbs free energy. See, in this manner they are asking. So the answer is D. Right? Okay, done. Next. I hope it is clear. This type of the questions they will ask you to make you confused. You have to be very careful with this type of the questions when they are asking. Next one. State of the system. What is the meaning of the state of the system means? What is the meaning of the state of the system means? See, if all the thermodynamic parameters are fixed. Now if I want to do the reaction, now this is a one ideal gas. Now the thermodynamic parameters I was fixing temperature, pressure, number of moles, volume. Then at least by changing one thermodynamic parameter. At least by changing the one thermodynamic parameter, now the state of the system will be changed. Let's suppose this is a 300 Kelvin, 1 atm, now 10 moles and the 10 ml. Now by changing temperature, now my state of the system has been changed. Now my state of the system has been changed. Clear? Now this we call it as a initial state. This we call it as a initial state, and this one we call it as a final state. Now what is the meaning of the state of the system means? The property in which the thermodynamic parameters are the property in which all the thermodynamic properties are fixed by changing at least one thermodynamic parameter. Now the state of the system is changed, we call it as a what? State of the system it is changed is called as a final state. This is the initial state and this is the final state. This we call it as a state of the system. Done. And the next one, we are going to see that is a state function. Next we are going to see that is a state function. What is the meaning of the state function? Means, my dear friends, you have to be very careful with the state function and the intensive property. Many of the students, they are getting confusion between the state function as well as the intensive property. Any property which we can measure is called as a state function. Okay, any property which we can measure is called as a state property. So what is the proper definition of the state function? Means which depends only on initial and final state, does not depend upon path. Okay, state function, it will not depend upon the path, right? Now next, properties which we can measure, which we can measure or which we can see, which we can measure is called, comes under the state function. So what are the properties we can measure that are the state function? Now we'll see. Let's suppose this is our system. Now here we are having this gas, right? Now this gas pressure I can measure. So pressure will comes under the state function. Now I can measure this gas temperature. So temperature will comes under the state function. I can measure this system's volume. So volume can comes under the state function. I can measure the number of moles of the system. So moles will also comes under the state of the system. Clear? Next, internal energy, enthalpy, entropy, Gibbs free energy. This all will comes under the which one? State function. Clear? Now these are the examples for the state function. Any property which we can measure, it will comes under the state function. Done? Clear? Now, what is the meaning of the path function? Yes. Next, what is the meaning of the path function? My dear friends, you have to be very careful with this one. Now the path function, see here, let's suppose this is our system. Okay, this is our system. Path function means, with the example I will explain. Listen carefully, it will make you somewhat confused also. To make you to understand, I was explaining very clearly. Now listen. Here this is our system. This is our system. Now in this system, when I was giving the heat, what this gas has been absorbed the heat. Okay, this gas has been absorbed the heat. When this gas has been absorbed the heat, after the giving the heat, I just stopped the heat and I kept the ice here. What? I kept the ice here. Done? Where I kept the ice to my system, initially this is initial state. This is the initial state. Initial state, gas has absorbed some energy and this is a which one? Diathermic wall, and I kept the ice. When it has reached to the final, state, now there is no any ice at the final state. When there is no at any final state, means this ice has been melted initial state or final state or in between the path. This ice has melted in the path or initial state only it has melted, or when it has reached to the final state it has melted, or in the path it has melted. Ice in the path it has melted, right? Means here from this gas, what it has released? This gas has released what? This gas has released what? Due to that which energy this ice has been melted. Means this ice is giving some energy in the form of heat. When it is giving in the form of the heat, means this ice has been melted, and when it has reached to the final state, ice is not there, means in this path only heat is exchanging, means initial state and the final state it is not exchanging, means it is not depending upon the initial state and the final state, it is in the between of initial state and the final state only heat it is exchanging, right? So that's the reason work and heat will comes under the path function, it is not the state function. So we can measure the heat only in the path, only in the path only we can measure, not in the initial state and the final state. I hope it is clear, right? Now what is the meaning of the state function, sorry, what is the meaning of the path function? Means change in property depends upon path, only it will be depend upon the path. Example, work and heat, these are the example for the path function, right? Now next one, and the next one we are going to study, that is the one thermodynamic parameter, that it is a heat capacity. Heat capacity is a one extensive property. What is the meaning of the heat capacity? Means when the heat is transferred to the system, it raises the temperature of the system through it raises the temperature of the system, and increased temperature of the system it is directly absorbed by the heat. Means what it is saying, let's suppose this is our system. When for this system, when I was supplying the heat, what it will happen, system temperature will be increased, means how much temperature it has been increased, that it is directly proportional to the heat supplied is directly proportional to the change in temperature of the system. Let's suppose initially its temperature is 100 degrees Celsius, will let us assume. When I was supplied the temperature, now it has reached to the 500 degrees Celsius. Now the amount of heat supplied I will get to know in the difference of this temperature only, right? So the amount of heat supplied will be directly proportional to the change in temperature of the system. So if I was remove this proportionality constant, I will get the one new constant, that is C, and it is a delta T. Now heat capacity will be equal to the Q by delta T. Now this is a heat capacity formula. This is a heat capacity formula, right? Now next one, specific heat capacity. Specific heat capacity. My dear friends, heat capacity is the extensive property or intensive property? Heat capacity is extensive property, you have to be very careful. Why it is extensive property, I will say. Let's suppose this is my 10 moles of system. This is my 10 moles of system. When I was supplied the heat to my 10 moles of system, I found that for the 10 moles of system, I found that 10 kilojoules of energy. Let's take 100 moles will take better. 100 moles will take. Okay. For the 100 moles, I found that 10 kilojoules of energy. Next, when I was changed the mass to the 5 or 50 moles, when I was changed the mass to the 50 moles, now the heat supplied, I found that for the 50 moles, I found that it is having the 5 kilojoules of energy. Means when I was changing the mass of the system, what heat capacity of the system is also changing. Means it is depending upon the mass. Mass dependent property will comes under the which one? Extensive property, right? Done. What is the meaning of the specific heat capacity? Specific heat capacity means heat required to raise the temperature of 1 gram of substance, 1 gram of substance through 1 degree, through 1 degree. Through 1 degree we call it as a specific heat capacity. Now you see, let's suppose I will take this is 100 gram of substance. This is a 100 gram of substance. For this 100 gram of substance, when I was giving the heat, I found that it is having the 10 kilojoules of energy. Now, from this 100 gram, I will take 1 gram. If I take the 1 gram and if I was supplied the heat, how much heat I was required for this 1 gram, I want to calculate. So, from this 100 gram, I was taken the 1 gram. So, for the 100 gram, 10 kilojoules means for 1 gram, how much it will become? 1 gram, how much it will become? For the 100 gram, oh sorry, we'll take better in reverse, we'll take. So 10 gram, if it is requiring the 100 kilojoule, then for the 1 gram, how much it will become? Here also we'll take the better, we'll take higher heat we require, right? Here also we'll take reverse. 10 moles, 100 kilojoules. Here also 5 moles, 50 kilojoules. Okay. Now 10 grams, 100 kilojoules means now 1 gram, it will become, no. 10 gram of the substance require 100 kilojoules of the energy means, then for the 1 gram of the substance require how much? 1 gram. Then it will become 10 kilojoules, right? Now, next another substance I will take. Now, this is a 5 gram of the substance. For the 5 gram of the substance, I found that 50 kilojoules of the energy. From these 5 grams, I was taking only 1 gram. For the 1 gram, I required 10 kilojoules, right? Now, whatever may be the mass, you can see, whatever may be the mass you have taken, for that mass, if you take only 1 gram from it, and if you cross check the heat, that you are getting 10 kilojoules only. In both the cases, 10 kilojoules only you are getting. If I change the mass also, for the 1 gram, I was getting 10 kilojoules only. I was taken the 10 gram. From that 10 gram, I was taken only 1 gram. And I got the 10 kilojoules of energy. Next, I was changed the mass. I was taken the 5 gram. In that 5 gram, I was taken only 1 gram. And I was cross-checked the heat capacity. I got the 10 only. Means, whatever may be the mass I was changing, in that mass, if I take the 1 gram, but heat capacity I was getting fixed. So, all the fixed property will comes under intensive property. So, specific heat capacity is the intensive property. This you have to be very careful. You have to be very careful with this one. Intensive property. Then, now, specific heat capacity formula. Specific heat capacity will be represented by the S. Now, S is equal to heat capacity by mass. Heat capacity is Q by delta T and into the mass. Now, by this we will get a one formula. Q is equal to ms delta T. This is a one beautiful formula we got. Right? Right. Next one, we are having the one thermodynamic process. Now, what are the thermodynamic processes we are having? What are the 4 thermodynamic processes we are having? Can anyone? What are the thermodynamic processes we are having? What are the 4 thermodynamic processes we are having? What are the 4 thermodynamic processes we are having? Isothermal, isobaric, adiabatic, isothermal, and next one is a isochoric. Right. Now, 4 4th thermodynamic parameters we are having. First one, yes. 4 thermodynamic parameters we are having. What is the meaning of the thermodynamic process? Means operation in which we can change the state of the system. We can change the state of the system is called thermodynamic process. Is called thermodynamic process. First one, my dear friends, you have to be very careful with this one. This isothermal process will make you somewhat confused, but it is a very high concept it is having in the isothermal process. In the isothermal process, we know temperature is constant. Okay, temperature is constant. Now here, what is the meaning of the thermo or isothermal process? Means state of the system changing, state of the system changing against constant temperature. Now you see, against the constant temperature, state of the system is changing. So here isothermal process means temperature is constant, but not the heat. You have to be very careful, and they will make you confused by giving the which one with the statement based question. In the isothermal process, heat also will be constant. Heat, my dear friend, heat is not constant in the isothermal process. Only the temperature is constant, but heat it will run. How, sir? Now listen. Let's suppose ice will take. Better, I will explain on the basis of the graph. It will be very clear for you. Now, if heat constant will become adiabatic, but in the isothermal process, heat is not constant. Heat it will keep on running. Okay. Now, for here, let's suppose this ice temperature is minus 10 degrees Celsius. Okay, this ice temperature is minus 10 degrees Celsius. Then this is a 0, right? Now this is a 100. Now when I was supplying the heat to this system or this water, let us assume for this water, when I was supplying the heat, now when I was supplying the heat, what is my system is doing? My system is absorbing the heat which I was applying. So when I was applying the heat to my system, it has came to 9, 8, 7, what temperature, and this is a phase, right? Now up to 0 degree it has came, means from the minus 10 degree to until 0 degree temperature, what my system is doing? System is increasing its temperature. When it has reached to the 0 degree, what it has become, whatever may be my system which is in the solid, at 0 degree it will changing its phase. State of the system is changing, right? From the solid to it has reached to the liquid, but my heat is constant, but temperature is became constant, but state of the system has been changed. See, heat is continuously I was giving. How it has changed its system? Due whatever may be the heat when I was supplied when it is in the minus 10 degree, that it is utilized to break the hydrogen bondings at the 0 degree. We know H2O contain 4 hydrogen bonding. Now whatever may be the 4 hydrogen bondings it is formed, that at whatever may be the energy it has been absorbed, that energy absorbed is utilized to break the hydrogen bondings of the H2O at the 0 degrees Celsius. Due to that, it will be changes from the solid to liquid. Then again when I was applied the heat, again it will reach to the 100 degree. At 100 degree from the H2O liquid, it will be converted into the H2O gas. Again it will be, but I was not stopping the heat to the system, right? See, it is continuously giving, but only at its constant temperature my system is changing its phase. You can see my system is changing again at the constant temperature only, my system is changing its phase. but heat it is not constant. My dear friends, you have to be very careful with this one. I hope it is clear. I hope it is clear. Means here in the isothermal process only the temperature is constant. Due to the temperature constant only my system is changing the phase but not the heat. Right. Next one. Second one. Yes. Second one is a isochoric process. Isochoric process means, now in the isochoric process which is constant? State of the system changed against the, now isochoric process means, now volume is constant, right? Now third one, isobaric process. Isobaric process means pressure is constant. Now fourth one, adiabatic process. Adiabatic process means Q is equal to 0. Now these are the some thermodynamic parameters we have studied, right? Next one, we are going to study the cyclic process. My dear friends, you have to be very careful. One statement based question I will ask you. What is the meaning of the cyclic process? Means after n operations, if the obtained state is exactly equal to initial state. Obtained state is exactly equal to the initial state is known as cyclic process. My dear friends, what is the meaning of the cyclic process? Means, let's suppose P versus V graph I will take. P versus V graph. Okay. This is my system. Okay. This is my system. For my system, it is having the volume. Initially, it is having the volume 10 ml. Let us assume. Done. Initially, my system, it is having the 10 ml volume. And the pressure, it is 1 atm. Let us assume. From 10 ml volume, it has been increased to the 20 ml volume against constant pressure. After that, from B, it has reached to the C. Okay. From C, again it has reached to the A. Started with the 10 ml and 3 atm pressure, let us assume. Started with the 10 ml and reached to the 10 ml. Change in volume will be started with 10, reached to the 10. Change in pressure will be started with 3, reached with the 3. Means in the cyclic process, whatever may be the state functions we are having, it is getting 0 or non-zero. Whatever may be the state functions we are having, that we are getting, it is 0 or non-zero. Clear? Now whatever may be the state function we are having, in the cyclic process you have to be very careful. So I can say, right? So in the cyclic process, state function parameters are 0. The state function parameters are 0 in the cyclic process, but not the path function. You have to be very careful. In the cyclic process, path function will not be 0, because path function work can be under the PV curve area under the curve will give you the PV curve. Area under the curve will give you the work done in the cyclic process. For the cyclic process, only the state function parameters are constant, not the path function parameters, right? And the next very important and the beautiful concept of our entire thermodynamics will be depend that it is reversible and the irreversible process. Okay, what is the meaning of the reversible and what is the meaning of irreversible process? Entire thermodynamics, we are having the n number of work done formulas. Okay, work done formulas for the compression and the expansion in the reversible and the irreversible process. So first of all, I will explain what is the meaning of reversible and what is the meaning of irreversible. Let's suppose this is my system. This is my system. Okay, now here also my system, it is there. This is a one movable piston. This is a one movable piston. In this movable piston, initially this volume is 10 ml. Here also this volume is 10 ml. Now this is a P gas. Now this is a one P external gas, P external pressure. Now this piston of our system has become constant here. Why? Why my system, why this piston has become constant here? Why in the reversible process, why the system volume has become 10 ml? Why? Why the piston has become equilibrium? Because P external gas has been equal to the P gas will be equal to the P gas will be equal to the P external gas. Done? Now what I was doing, just I was dropped the one very small stone to the system. When I was dropped the one small stones to the system, what happened? Volume will change very negligible, right? Very negligible change in the volume will cut. Very negligible change when we get, when the system will also will change. When I was dropped the one small piece of stone, state of the system will be changed. When the state of the system has been changed, volume will be very negligibly changed, right? Means volume will become 9.9999 ml, right? Means when the system is changing, at the same time volume change also I was seeing. Means in the reversible process, first point, key point you have to remember that only the first key point you have to remember in the reversible process means for every change we can see volume change. We can see volume change. Means every change in the system we can see the volume change. Means each step we can say P gas is equal to P external gas. This is the one key point. If you remember, whatever may be the question they may ask from the reversible process, you will never and ever you will do the mistake. This is the key point you have to remember. Means in the P gas is directly or each step or whenever if I want to state or change the system, each step P gas will be equal to the P external gas. This is about the reversible process, and some points are there. This is a slow process, this is hypothetical multi-step process, but very key point you have to remember in the reversible process is this one. P gas is each step P gas is equal to P external gas. Now comes to the irreversible process. Now comes to the irreversible process. In this irreversible process, what I was doing, now this is a P gas, now this is a P external gas. Now I was taking the 100 kg of mass, 100 kg of stone I was taking. 100 kg of the stone when I was dropped to the system, what it will happen? of the system will compress very fastly or very slowly. Very fastly the system has been compressed and it has came to the 5 ml, right? And after the 5 ml, P gas, now this is a P external gas, this is a P2, P external gas final pressure. Now here when I was dropped the 100 kg of the mass, what happened? Now this mass has become stopped at the which one? At a 5 ml. Now this it has been happened against the constant external pressure or with the when the system is changing, are you seeing the any how to say, let's suppose when I was dropped the 100 kg of the mass, now system has been changed its phase from the 10 ml to the 5 ml. Now this has happened against the constant external pressure, without any constant external pressure it has happened, or with the every change in the volume we can see the constant external pressure or we can see the volume change. Means I was asking the question is, when the system has changed its phase, can we see its volume change? Can we see its volume change? Or when it has reached to the final state only, can we see its volume change? Is my question is clear or should I explain once again? Actually my question is, నేను ఏమంటున్నా అంటే, నేను ఎప్పుడైతే ఈ సిస్టమ్ యొక్క ఫేస్ని చేంజ్ చేస్తానో ఆ సిస్టమ్ యొక్క ఫేస్ చేంజ్ అయ్యే టైంలో దాని వాల్యూమ్ చేంజ్ నేను చూడగలుగుతున్నానా, లేదంటే అది ఫైనల్కి రీచ్ అయిన తర్వాతనే దాని వాల్యూమ్ చేంజ్ చూడగలుగుతున్నానా అని అడుగుతున్నాను. మీన్స్ ఎగ్జాంపుల్, బెస్ట్ ఎగ్జాంపుల్ ఐ విల్ టేక్ ద బెలూన్. ఇప్పుడు బెలూన్ తీసుకోండి, ఆ బెలూన్లో సర్టెన్ గ్యాస్ ఉంటుంది కదమ్మా. ఇఫ్ సపోజ్ దిస్ ఈజ్ అ బెలూన్, ఆ బెలూన్లో సర్టెన్ వాల్యూమ్ ఉంది. ఇప్పుడు ఈ బెలూన్లో ఉన్న వాల్యూమ్కి ఇఫ్ ఐ వాజ్ గివెన్ ద ఫైర్, ఇప్పుడు ఫైర్ ఇస్తే ఏమైపోతుంది, బస్ట్ అయిపోతుంది కదా. వెన్ ఇట్ హాస్ బికెమ్ బస్ట్, దాని వాల్యూమ్ చేంజ్, ఎంత వాల్యూమ్ చేంజ్ అయింది అనేది నేను ఎట్లా చూస్తాను? ఐ కెనాట్ సీ అంటిల్ ఇట్ రీచ్ టు ద ఫైనల్ స్టేట్. అంటే దీని వాల్యూమ్ చేంజ్ ఎందుకు అవుతుంది? ఎక్స్టర్నల్ ప్రెషర్ అనేది కాన్స్టాంట్ ఉండడం వల్లనే దాని వాల్యూమ్ చేంజ్ అనేది అవుతుంది. ఎక్స్టర్నల్ ప్రెషర్ అపోజ్ చేసిందంటే అది వాల్యూమ్ చేంజ్ ఎందుకు అవుతుంది? ఇప్పుడు ఇక్కడ ఎక్స్టర్నల్ ప్రెషర్, పీ గ్యాస్ ప్రెషర్ రెండు కాన్స్టెంట్ ఉన్నాయి కాబట్టి పిస్టన్ ఇక్కడ ఆగిపోయింది. ఇక్కడ కూడా ఫైనల్ స్టేట్కి వచ్చిన తర్వాత ఇక్కడ పిస్టన్ ఆగిపోయిందంటే ఎక్స్టర్నల్ గ్యాస్, పీ గ్యాస్ ప్రెషర్ రెండు సేమ్ అయినాయి. అదే ఒకవేళ ఎక్స్టర్నల్ గ్యాస్ ప్రెషర్కు దాన్ని అపోజ్ చేస్తే వాల్యూమ్ చేంజ్ అవ్వకూడదు కదా. ఇక్కడ చేంజ్ అవుతుంది అంటే మీన్స్ ఇర్రివర్సబుల్ ప్రాసెస్ ఆర్ హ్యాపెనింగ్ అగైన్స్ ద కాన్స్టాంట్ ఎక్స్టర్నల్ ప్రెషర్. మీరు క్వశ్చన్లో కాన్స్టాంట్ ఎక్స్టర్నల్ ప్రెషర్ అనే ఒక టర్మ్ చూసినారంటే బ్లైండ్గా గుర్తుపెట్టుకోండి, అది ఇర్రివర్సబుల్ ప్రాసెస్. డైరెక్ట్లీ ఇర్రివర్సబుల్ ప్రాసెస్ వర్క్ డన్ ఫార్ములా యూజ్ చేసి డైరెక్ట్ సాల్వ్ చేసేసారు. యూ హ్యావ్ టు జస్ట్ ఇఫ్ యూ సీ ఇన్ ద క్వశ్చన్ కాన్స్టాంట్ ఎక్స్టర్నల్ ప్రెషర్, అంతే. అంతకు మించి మీకు వేరే అసలు ఏ వర్క్ డన్ ఫార్ములా యూజ్ చేయాలి అన్న డౌటే అవసరం లేదు. ఇఫ్ యూ సీ ఇన్ ద క్వశ్చన్ కాన్స్టాంట్ ఎక్స్టర్నల్ ప్రెషర్, డైరెక్ట్లీ యూజ్ ద ఇర్రివర్సబుల్ వర్క్ డన్ ఫార్ములా. ఎందుకు కాన్స్టెంట్ అవుతుందన్నా ఇక్కడ చూడు. ఇప్పుడు సరే, రివర్సబుల్లో కాన్స్టెంట్ ఎక్స్టర్నల్ ప్రెషర్ ఎందుకు కాన్స్టెంట్ అవ్వదు అని అడిగినావు, రైట్. మళ్ళొకసారి క్లియర్గా చెప్తా ఈయనకు. ఓకేనా? నా ఇప్పుడు ఇది గ్యాస్, ఓకేనా? ఇది ఒక హైపోథెటికల్ ప్రాసెస్. రివర్సబుల్ అనేది ఒక హైపోథెటికల్, ఫస్ట్ థింగ్ గుర్తుపెట్టుకో, ఇది ఒక హైపోథెటికల్ ప్రాసెస్, రైట్. ఓకేనా? నా ఇది పీ గ్యాస్ కదా, ఇది పీ ఎక్స్టర్నల్. నేను ఇప్పుడు ఇక్కడ 100 kg తీసుకున్నా, ఇర్రివర్సబుల్లోనేమో 100 kg ఆఫ్ మాస్ తీసుకున్నా. ఇప్పుడు ఇక్కడ నేను తీసుకుంటుంది 0.0000001 kg ఆఫ్ మాస్ తీసుకుంటా. అంటే చిన్న స్టోన్ తీసుకుంటా, దీని వాల్యూమ్ వచ్చేసి 10 ml. ఇప్పుడు నేను ఒక చిన్న స్టోన్ని ఈ సిస్టంలోకి వేస్తే నాకు ఈ సిస్టంలో వచ్చిన వాల్యూమ్ చేంజ్ ఎంత? ఈ సిస్టంలో వచ్చిన వాల్యూమ్ చేంజ్ ఎంత? ఈ 10లో నుంచి 0.00000001 ml చేంజ్ వచ్చింది. అంటే ఈ కంపారిజన్ విత్ ద 10 mlలో 0.0001 ml అనేది హైయా వెరీ నెగ్లిజిబులా? నెగ్లిజిబుల్ చేంజ్ ఆఫ్ వాల్యూమ్ వచ్చింది కదా. మరి నెగ్లిజిబుల్ చేంజ్ ఆఫ్ వాల్యూమ్ వచ్చిందంటే ఈచ్ స్టెప్లో పీ గ్యాస్ పీ ఎక్స్టర్నల్ గ్యాస్ రెండు సేమే ఉన్నాయి కదా. ఇక్కడ వాల్యూమ్ నీకు పెద్దగా చేంజ్ అవ్వలే కదా నాన్న. ఇప్పుడు 10 mlలో 0.0001 ml చేంజ్ అయింది అని అంటే స్టార్టింగ్లో పీ ఎక్స్టర్నల్ పీ గ్యాస్ రెండు సేమే ఉన్నాయి. నువ్వు చిన్న స్టోన్ వేసిన తర్వాత నీకు ఇంత చేంజ్ ఆఫ్ వాల్యూమ్ వచ్చింది. మరి ఇంత చేంజ్ ఆఫ్ వాల్యూమ్ 10 mlలో చాలా నెగ్లిజిబులే కదా. నెగ్లిజిబుల్ అంటే మరి పీ ఎక్స్టర్నల్ గ్యాస్ పీ గ్యాస్ అనేది సేమే కదా. అందుకే రివర్సబుల్ ప్రాసెస్లో పీ గ్యాస్ పీ ఎక్స్టర్నల్ గ్యాస్ ఈచ్ స్టెప్లో రెండు సేమే ఉంటాయి. అదే అంటున్నా నాన్న, ఈచ్ అండ్ ఎవ్రీ స్టెప్ పీ గ్యాస్ పీ ఎక్స్టర్నల్ గ్యాస్ రెండు సేమే అని అంటున్నా నేను. ఇక్కడ నేను కాన్స్టెంట్ అంటలేను, రెండు సేమ్ అంటున్నా. ఐ వాస్ నాట్ సేయింగ్ హియర్ ద పీ ఎక్స్టర్నల్ ఈస్ కాన్స్టెంట్. నేనేం చెప్తున్నా అంటే ఇప్పుడు నేను చిన్న స్టోన్ వేసినప్పుడు నా సిస్టమ్ ఇంత వాల్యూమ్ చేంజ్ చేసింది, ఎంత 0.001 ml వాల్యూమ్ చేంజ్ చేసినప్పుడు ఒక్కటే అక్కడ నెగ్లిజిబుల్ వాల్యూమ్ చేంజ్ అయిపోయింది అని అంటే మరి ఇన్ని స్టార్టింగ్ లెక్కనే ఉంది కదా. పీ గ్యాస్కి పీ ఎక్స్టర్నల్ గ్యాస్ రెండు సేమ్ అయిపోయినాయి కదా. అంటే ఎవ్రీ చేంజ్ ఆఫ్ వాల్యూమ్ ఇన్ ద సిస్టమ్ పీ గ్యాస్ ఇంకా పీ ఎక్స్టర్నల్ గ్యాస్ రెండు సేమ్ ఉండడం వల్లనే ఆర్ వాల్యూమ్ చేంజ్ ఇట్లా ఉండడం వల్లనే వాల్యూమ్ చేంజ్ చూడగలుగుతున్నా అని చెప్తున్నా నేను. క్లియర్ అయిపోయిందా? సరే, మళ్ళీ ఒకసారి క్లియర్గా చెప్తా ఒకసారి. ఇప్పుడు దిస్ ఈజ్ వన్ పీ గ్యాస్, ఓకే. నౌ దిస్ ఈజ్ అ one P external, this is a P external gas, now this is a P gas, right? Now here the volume is 10 ml, okay. First I was dropped the one small stone. Now when I was dropped the one small stone, then system has changed its volume to the 9.999999 ml, okay. So ikkada వాల్యూమ్ వెరీ నెగ్లిజిబుల్లో చేంజ్ అయినప్పుడు, నెగ్లిజిబుల్ చేంజ్ ఆఫ్ వాల్యూమ్ అయినప్పుడు ఇక్కడ పీ గ్యాస్ ఇంకా పీ ఎక్స్టర్నల్ గ్యాస్ ఆల్మోస్ట్ ఈక్వలే ఉన్నాయి. తర్వాత నెక్స్ట్ ఇంకొక స్టోన్ వేసినప్పుడు వాల్యూమ్ చేంజ్ ఎంత అయిపోయింది అని అంటే 9.99998 ml అయింది. అప్పుడు కూడా వాల్యూమ్ చేంజ్ వెరీ నెగ్లిజిబుల్లో చేంజ్ అయినప్పుడు కూడా పీ గ్యాస్ ఈజ్ ఈక్వల్ టు పీ ఎక్స్టర్నల్ గ్యాస్ అంటే నేను ఎవ్రీ స్టెప్ ఆఫ్ చేంజింగ్ ద సిస్టమ్ అంటే నేను ఒక్కొక్క స్టోన్ని వేసి సిస్టమ్ యొక్క వాల్యూమ్ని చేంజ్ చేస్తున్న టైంలో ప్రతి స్టెప్లో పీ గ్యాస్ ఈజ్ ఈక్వల్ టు ఆర్ ఆల్మోస్ట్ ఈక్వల్ టు ద పీ ఎక్స్టర్నల్ గ్యాస్ అని చెప్తున్నా. అంటే రివర్సబుల్ ప్రాసెస్లో పీ ఎక్స్టర్నల్ అనేది కాన్స్టెంట్ ఉండదు, రెండు సేమ్ ఉంటాయి అంటున్నా, ఆల్మోస్ట్ సేమ్ ఉంటాయి అంటున్నాను. కాకపోతే ఇక్కడ చూడు ఇర్రివర్సబుల్లో ఇప్పుడు బెలూన్ ఉంది, ఈ బెలూన్కి సర్టెన్ ఇంత వాల్యూమ్ ఉంది, 10 ml ఉంది. మరి ఇప్పుడు ఈ 10 ml నుంచి దీనికి సడన్గా నేను ఒక ఫైర్ ఇచ్చిన, మరి ఇది ఒక్కటేసారి సడన్గా ఈ బెలూన్ పలిగిన తర్వాత దీని వాల్యూమ్ అనేది పెరిగిపోయింది, సరౌండింగ్లోకి వచ్చేసి వాల్యూమ్ అనేది పెరిగిపోయింది. మరి ఇప్పుడు ఈ వాల్యూమ్ ఎంత పెరిగింది అని నాకు ఎప్పుడు తెలియాలి? దీంట్లో ఉన్న ప్రెషర్ దీంట్లో ఉన్న గ్యాస్ మొత్తం సరౌండింగ్ ప్రెషర్లోకి వచ్చిన తర్వాత, సరౌండింగ్ ప్రెషర్తో వచ్చిన తర్వాత అది ఫైనల్ ఒక ఫైనల్ స్టేట్కి వచ్చిన తర్వాతనే నాకు అంత తెలుస్తుంది. అంటే ఇది ఫైనల్ స్టేట్కి వచ్చే వరకు ఎక్స్టర్నల్ ప్రెషర్ అనేది దాన్ని ఆపడం లేదు కదా. ఇప్పుడు ఆ ఎక్స్టర్నల్ ప్రెషర్ అనేది ఆపితే వాట్ ఇట్ ఈస్ నాట్ కాన్స్టెంట్, అంటే అది వాల్యూమ్ చేంజ్ అవ్వదు. అక్కడ ఎక్స్టర్నల్ ప్రెషర్ అక్కడ కాన్స్టెంట్ ఉండడం వల్లనే దాని వాల్యూమ్ చేంజ్ అనేది మొత్తం అయిపోతుంది. సేమ్ థింగ్ ఇక్కడ కూడా ఒకటేసారి 100 kg ఆఫ్ మాస్ నేను వేసి కంప్రెస్ చేయగానే ఇది 5 ml ఈ 10 ml నుంచి 5 mlకి వచ్చే వరకు ఆ ఎంత వాల్యూమ్ చేంజ్ అనేది నేను చూడలేదు. నేను ఎప్పుడు ఆ 5 ml వరకు వచ్చింది ఎప్పుడు చూసినాను, అది ఫైనల్ ప్రెషర్ అంటే దాని ఫైనల్ స్టేట్కి వచ్చి పిస్టన్ ఆగిపోయిన తర్వాత అప్పుడు మాత్రమే చూసిన. అంటే అది కాన్స్టాంట్ ఎక్స్టర్నల్ ప్రెషర్ దాన్ని అపోజ్ చేయడం లేదు కాబట్టి ఆ గ్యాస్ అనేది కంప్రెస్ అయింది. ఒకవేళ అది కాన్స్టాంట్ ఎక్స్టర్నల్ ప్రెషర్ ఒకవేళ దాని ఏమంటారు, ఇఫ్ ఇట్ ఈస్ నాట్ అపోజింగ్, అది వాల్యూమ్ చేంజ్ అవ్వదు. అర్థమైందా? అందుకే ఇర్రివర్సబుల్ ప్రాసెస్ అనే వర్డ్ చూస్తే వన్ థింగ్ యూ హ్యావ్ టు రిమెంబర్, రివర్సబుల్ and one is irreversible. Reversible and one is a irreversible. Reversible, it is a hypothetical. It is a hypothetical process. Okay. Now, slow process. Each step we can see the volume change, right? So we can say P gas almost equal to the P external gas, right? Now ikkada it is a naturally occurring process. Irreversible process are naturally occurring process. Single step process means here this process will be happen against the constant external pressure. ఈ టర్మ్ యూ హ్యావ్ టు రిమెంబర్. ఇది గుర్తుపెట్టుకుంటే చాలు. నీకు వర్క్ డన్ ఫార్ములా ఇచ్చిన క్వశ్చన్ రివర్సబుల్లో అడుగుతుండా ఇర్రివర్సబుల్లో అడుగుతుందా అని ఈ ఒక్క క్వశ్చన్ టర్మినాలజీలో ఇది చూసి మనం చెప్పొచ్చు. సో కాన్స్టెంట్ ఎక్స్టర్నల్ ప్రెషర్ కదా, కాన్స్టెంట్ ఎక్స్టర్నల్ ప్రెషర్ అంటే P external will be equal to the final pressure. P external will be equal to the final pressure. Okay, these are the two terms you have to remember for the reversible and the irreversible. అంతే, అంతకు మించి ఎక్స్ట్రా కూడా గుర్తుపెట్టుకోవాల్సిన అవసరం లేదు. రివర్సబుల్ ఇర్రివర్సబుల్ అంటే అర్థమైపోయింది కదా. స్లో ప్రాసెస్, ఫాస్ట్ ప్రాసెస్, అండ్ ఇన్ ద రివర్సబుల్ ప్రాసెస్ ఈచ్ స్టెప్ వీ కెన్ సీ ద P gas and the P external, almost it will be same. But irreversible process we can see the volume change only when it has reached to the final. So P external will be equal to the final pressure. Okay na? Right. Next. First let me complete the concept. ఇంకా రివర్సబుల్ వర్క్ డన్, దాని కాన్సెప్ట్ అయిపోయిన తర్వాత క్వశ్చన్ స్టార్ట్ చేద్దాం. ఓకేనా? ఆల్మోస్ట్ ఇట్ హాస్ బికేమ్ 1.5 hours, సో ఐ వాస్ నాట్ గివింగ్ ఎనీ క్వశ్చన్స్ కదా, because thermodynamics is a very vast and a very big and very important chapter. We are having the n number of concepts. Next one thermodynamic parameter we are going to study, that is a internal energy. That internal energy we can represent with the E and U. Internal energy endi anante, you have to be very careful. Now this is my system. Okay, this is my system. My dear friends, you have to be very careful. Ikkada inandi, clear ga inandi. This is my system. Here this is a one gas. Okay na? Here every substance possesses some energy internally, is called as the internal energy. Okay na? Internal energy of the system will be measured at a constant volume ఇంకా కాన్స్టెంట్ టెంపరేచర్ దగ్గర మాత్రమే ఇంటర్నల్ ఎనర్జీ we can measure. Clear? Why only we can measure the internal energy at only constant volume and a constant temperature? Because see, every system having energy internally. Why every system is having energy internally? Because this is a one gas. Gas is having internal energy E is equal to, due to the potential energy plus kinetic energy of the gas. So potential energy of these gas particles, potential energy we will get due to repulsion, due to attraction, due to the repulsion, due to the attraction between the gas molecules. Kinetic energy will get through the translational energy plus rotational energy plus vibrational energy plus electronic energy. So each gas will have potential energy. Potential energy ఈ gas molecules కి ఎలా వస్తున్నాయి? Potential energy when this gas particle and this gas particle are attracting. When this gas particle and this gas particle are repelling. This gas particle and this gas particle nucleus are repelling. This gas particle electron, this gas particle electron are repelling. This gas particle electron and this gas particle nucleus are attracting. Due to the attraction and repulsion, what potential energy is developing. Okay na? Right. Translational energy, kinetic energy, vibrational energy, electronic energy, I will explain with the equipartition energy now. Here, internal energy, these gas particles to move, what it requires? ఇప్పుడు మన ఈ యొక్క సిస్టంలో ఈ సిస్టమ్కి ఇంటర్నల్ ఎనర్జీ ఉందని చెప్తున్నాను నేను. ఇంటర్నల్ ఎనర్జీ ఉందని నేను ఎలా చెప్పాలి? ఈ గ్యాస్ పార్టికల్ పొటెన్షియల్ ఎనర్జీ వల్ల ఇంటర్నల్ ఎనర్జీ వస్తుంది. ఈ గ్యాస్ పార్టికల్ కైనెటిక్ ఎనర్జీ వల్ల ఇంటర్నల్ ఎనర్జీ వస్తుంది. పొటెన్షియల్ ఎనర్జీ వల్ల ఇంటర్నల్ ఎనర్జీ వస్తుంది దీనికి సిస్టమ్కి. ఈ క్లోజ్డ్ కంటైనర్ కదా, క్లోజ్డ్ కంటైనర్ అంటే ఆబ్వియస్లీ వాల్యూమ్ కాన్స్టెంట్ అయిపోతుంది. మరి ఈ గ్యాస్ పార్టికల్ పొటెన్షియల్ ఎనర్జీ ఎట్లా డెవలప్ చేస్తుంది, కైనెటిక్ ఎనర్జీ ఎట్లా డెవలప్ చేస్తుంది? దట్ కెన్ ఎనీవన్? ఈజ్ మై క్వశ్చన్ ఈస్ క్లియర్? నేను అడిగిన క్వశ్చన్ క్లియర్గా ఉందా? అర్థమైందా? కొలిజన్స్, గుడ్. ఆ కొలిజన్ కి ఎనర్జీ ఎక్కడి నుంచి వచ్చింది? దానికి ఆ కొలిజన్ అవ్వడానికి ఎనర్జీ ఎక్కడి నుంచి వచ్చింది అని అడుగుతున్నాను నేను. ఆ కొలిజన్ అవ్వడానికి ఎనర్జీ ఎక్కడి నుంచి వచ్చింది? హీట్ కదా, అంటే టెంపరేచర్. అంటే ఇప్పుడు ఈ టెంపరేచర్ వల్లనే కదా దీనికి ఈ గ్యాస్ పార్టికల్ మూవ్ అవుతున్నాయి. ఈ టెంపరేచర్ ఉండడం వల్లనే కదా ఈ గ్యాస్ పార్టికల్ మూవ్ అవుతున్నాయి. ఇప్పుడు నేను ఎగ్జాక్ట్ వాల్యూ ఆఫ్ ఇంటర్నల్ ఎనర్జీ కెన్ ఐ క్యాలిక్యులేట్? ఎగ్జాక్ట్ వాల్యూ ఆఫ్ ఇంటర్నల్ ఎనర్జీ కెన్ ఐ క్యాలిక్యులేట్? ఎగ్జాక్ట్ వాల్యూ ఆఫ్ ఇంటర్నల్ ఎనర్జీ కెన్ ఐ క్యాలిక్యులేట్? ఇప్పుడు ఎగ్జాక్ట్గా ఇంటర్నల్ ఎనర్జీ నేను క్యాలిక్యులేట్ చేయగలుగుతానా? కెన్ ఐ క్యాలిక్యులేట్ ఇట్ ఆర్ నాట్? నో. ఎందుకు? ఎగ్జాక్ట్ వాల్యూ ఆఫ్ ఇంటర్నల్ ఎనర్జీని నేను క్యాలిక్యులేట్ చేయలేను. ఎందుకు అని అంటే ఇప్పుడు ఈ గ్యాస్ ఏదైతే ఉందో, వాట్ ఎవర్ మే బి ద గ్యాస్ వీఆర్ హ్యావింగ్, ఇప్పుడు ఈ గ్యాస్ రెండు అట్రాక్ట్ అయ్యి ఒక పొటెన్షియల్ ఎనర్జీ ఇస్తుంది. ఈ గ్యాస్ రెండు రిపల్షన్ అయ్యి ఒక పొటెన్షియల్ ఎనర్జీ ఇస్తుంది. అంటే ఈ రెండు అట్రాక్షన్ రిపల్షన్ వల్ల డిఫరెంట్ పొటెన్షియల్ ఎనర్జీ, కైనెటిక్ ఎనర్జీ వస్తడం వల్ల ఎగ్జాక్ట్లీ నేను క్యాలిక్యులేట్ చేయలేను. అందుకోసమే నేనేం చేసిన, కాన్స్టెంట్ టెంపరేచర్ పెట్టిన. టెంపరేచర్ కాన్స్టెంట్ పెట్టినాడు అనుకో, ఈ రెండు గ్యాస్ పార్టికల్స్ మూవ్ అవ్వవు. ఈ రెండు గ్యాస్ పార్టికల్స్ మూవ్ అవ్వవు కాబట్టి కొలిజన్ అవ్వవు కాబట్టి ఆ టైంలో ఈ సిస్టమ్ యొక్క ఇంటర్నల్ ఎనర్జీ ఎంత అయితే ఉందో అంతే ఉంటుంది ఫిక్స్గా. అప్పుడు నేనేం చేస్తా, ఇప్పుడు ఒక టైము 10 అనుకుంటే 10:30కి టెంపరేచర్ కాన్స్టెంట్ చేసేసిన, వాల్యూమ్ అనేది ఫిక్స్డ్ కాన్స్టెంట్. ఎందుకు? ఇక్కడ ఇది క్లోజ్డ్ కంటైనర్ కాబట్టి వాల్యూమ్ అనేది కాన్స్టెంట్. ఇప్పుడు 10 AM దగ్గర దీని యొక్క ఇంటర్నల్ ఎనర్జీ ఒక 100 కిలోజౌల్స్ అనుకుంటే, మరి 10:30 దగ్గర సపోజ్ ఒక 200 అనుకుందాం. 200 లేదంటే తగ్గింది అనుకుందాం. చేంజ్ ఇన్ ఇంటర్నల్ ఎనర్జీ మాత్రమే నేను క్యాలిక్యులేట్ చేయగలుగుతాను. ఎగ్జాక్ట్ వాల్యూ ఆఫ్ ఇంటర్నల్ ఎనర్జీని క్యాలిక్యులేట్ చేయలేను. అది కూడా యూ హ్యావ్ టు రిమెంబర్, నేను ఎప్పుడైతే టెంపరేచర్ కాన్స్టెంట్ పెడతానో. అందుకే ఇంటర్నల్ ఎనర్జీ కెన్ బి మెజర్డ్ ఓన్లీ ఎట్ కాన్స్టాంట్ వాల్యూమ్ అండ్ కాన్స్టాంట్ టెంపరేచర్. ఈ కాన్స్టాంట్ టెంపరేచర్ మీరు పెట్టకపోతే ఇంటర్నల్ ఎనర్జీని క్యాలిక్యులేట్ చేయలేము. ఎందుకు? టెంపరేచర్ చేంజ్ లేదు కాబట్టి, కాన్స్టెంట్ లేదు కాబట్టి ఈ గ్యాస్ పార్టికల్ మూవ్ అవుతాయి. కాబట్టి ఇంటర్నల్ ఎనర్జీ చేంజ్ అవుతుంది. కాబట్టి మనం చేంజ్ ఇన్ ఇంటర్నల్ ఎనర్జీ క్యాలిక్యులేట్ చేయలేము. అందుకే ఎట్ కాన్స్టెంట్ వాల్యూమ్ అండ్ కాన్స్టెంట్ టెంపరేచర్ దగ్గర మాత్రమే వీ కెన్ క్యాలిక్యులేట్ ద ఇంటర్నల్ ఎనర్జీ. సో చేంజ్ ఇన్ ఇంటర్నల్ ఎనర్జీని క్యాలిక్యులేట్ చేస్తున్నాం కాబట్టే ఇట్ ఈస్ డిపెండింగ్ అపాన్ ద ఇనిషియల్ అండ్ ఫైనల్ స్టేట్ కాబట్టే దిస్ పారామీటర్ విల్ కమ్స్ అండర్ ద స్టేట్ ఫంక్షన్. మళ్ళా డిపెండింగ్ అపాన్ ద మాస్ చేంజెస్ ఇంటర్నల్ ఎనర్జీ చేంజ్ అవుతుంది కాబట్టి ఇది ఎక్స్టెన్సివ్ ప్రాపర్టీ. క్లియరా? ఐ హోప్ ఇట్ ఈస్ క్లియర్. సో ఎగ్జాక్ట్ వాల్యూ ఆఫ్ internal energy, exact value of internal energy, exact value of U and E cannot be calculated. First point, only change in internal energy can be calculated. Third, it is a extensive property. Okay. Fourth one will be the it is calculated. Exact value of internal energy cannot be calculated. It is a state function. It is a state function. Now these are the very good parameters that you have to remember. My dear friends, internal energy is directly proportional to the temperature or inverse. Ante temperature, internal energy is depending on the temperature or it is not depending on the temperature. Internal energy is depending on the temperature, it is not depending on the temperature. This point, if it is clear, in isothermal process you will not get confusion. In the isothermal process you will not get confusion. Depending. So this point also make it as note. Internal energy is depending on temperature. So this is also one key point you have to remember. If you remember this key point, you will not get any confusion. While we are deriving the reversible work done, depending. So this is also one key point you remember. Next one is the heat and work, but first I will explain about the heat. Now what is the meaning of the heat? When the temperature difference exists, when the temperature difference exists, energy flow from higher energy flows from higher to lower, understand? Higher to lower. Now heat is a disorder form of energy or order form of energy? నాకు చెప్పండి. Heat is a disorder form of energy or order form of energy? Heat is a disorder form of energy or order form of energy? Heat is a disorder form of energy or order form of energy? Now heat is a disorder form of the energy, right? Why the heat is disorder form of the energy? Now heat is a disorder form of energy. Why the heat is a disorder form of the energy? Because now let's suppose I will take one example. Here let's take, this is a one system. Now in the center of the system I will take the sticks. Okay, and if I fire the sticks, okay, from this is fire. Now here the gas particle, this is a gas particle, this is a gas particle, this is a gas particle, and some gas particles are also nearer to the fire. Now whatever may be the fire, it is coming from here, gas particle nearer to the fire will express some different heat, and gas particle which are far away from the heat will express the different heat, right? Means orderly we are not getting the energy. Means heat which we are nearer to that fire, gaseous particle which are nearer to the fire is having the different heat. Gaseous particle which are far away from them, it is having the different type of the heat. Means why the heat will be the order form of energy? Heat will be the disorder form of the energy. Disorder form of energy. Right? Now comes to the work. When it comes to the work is a order form of energy. Work is a order form of energy. work can be done orderly. We can do the work orderly. Now here the work we are having two types. Here the work we are having two types. One is a non-PV work and one is a PV work. What is the meaning of the non-PV work? That I will explain very clearly in the second law of thermodynamics when it has started. But PV work, it will play very crucial role. Only PV work means volume change if it is happened, that it is PV work. If volume is not changing but work is done, that is called as a non-PV work. వాల్యూమ్ చేంజ్ అవ్వకుండా వర్క్ చేసింది అంటే నాన్ పీవీ, వాల్యూమ్ చేంజ్ అవ్వకుండా వర్క్ చేసింది అంటే పీవీ, అంతే. అదొక్కటి గుర్తుపెట్టుకోండి. నెక్స్ట్, ఈ వర్క్ డన్ ఫర్ ద పీవీ. హౌ టు క్యాలిక్యులేట్ ద వర్క్ డన్ ఇన్ ద పీవీ? నౌ విత్ ద హెల్ప్ ఆఫ్ ద గ్రాఫ్, నౌ విల్ సీ. నౌ P versus V graph I will take. P versus V. P versus V graph లో, let's suppose I was taking the one piston. ఇప్పుడు నేను ఒక పిస్టన్ తీసుకున్నాను. వర్క్ టు బి డన్ అంటే మూవబుల్ పిస్టన్ ఉండాలి కదా, ఇది మూవబుల్ పిస్టన్. ఓకేనా? ఇది గ్యాస్. ఇప్పుడు ఈ గ్యాస్ యొక్క ఇనిషియల్ వాల్యూమ్, దిస్ ఇస్ ద ఇనిషియల్ వాల్యూమ్ ఆఫ్ ద గ్యాస్ V1. ఇప్పుడు ఈ గ్యాస్ ని కంప్రెస్ చేసిన ఇక్కడ వరకు ఎక్స్టర్నల్ ప్రెషర్, ఈ ఎక్స్టర్నల్ ప్రెషర్తోనే విత్ ద పి ఎక్స్టర్నల్, ఈ పి ఎక్స్టర్నల్ ఫోర్స్తోనే ఈ ప్రెషర్ ఎక్స్టర్నల్ ఫోర్స్ నేను ఈ పిస్టన్కి అప్లై చేయడం వల్ల ఇక్కడ V1 వాల్యూమ్ దగ్గర ఉండాల్సిన గ్యాస్ V2 వాల్యూమ్ దగ్గరకు వచ్చింది. ఎక్కడికి వచ్చింది? V2 వాల్యూమ్ దగ్గరకు వచ్చింది. ఇంత. ఓకేనా? ఇప్పుడు ఈ PV గ్రాఫ్లో ఫస్ట్ థింగ్ వర్క్, ఫస్ట్ వెరీ కీ పాయింట్ యూ హ్యావ్ టు రిమెంబర్ దట్ ఇట్ ఈస్ వర్క్ టు క్యాలిక్యులేట్ in PV graph, work to calculate in the PV graph, work to be calculated in the PV graph, that it is area under the curve. Area under the curve. Hi my dear friend, may I know your name? Area under the curve. May I know the student who is from the Mysore? Now the area under the curve will give you the work done. For the PV graph, area under the curve will give you the work done. Now from year to year, now against this is the pressure. Now this is the volume change from V1 volume to V2 volume. Now this is the area. This is area under the PV curve will give you the area under the PV curve will give you work done. Now this much work done, it has been done. This much area of the work, it has been done. So here from V1 volume to V2 volume, that it is called as a change in volume, right? Change in volume. How much volume it has been changed? This much area and this much volume it has been changed. Means change in volume will be equal to the area into length. Area into length. Then after that we have applied the pressure, right? Pressure applied. Pressure is equal to force by area. Now force of the piston will be equal to P external into area, right? Now work done formula or work done is equal to force into length. Work done formula will be force into length. Force formula P external into area into length. Area into length. So can I say work done is equal to P external into delta V, because area into length will be the change in volume. So work done will be equal to the P external delta V. But for my system, I did the work done on the system or work done by the system. Now say me, Now whatever may be the work done formula I was deriving for my system, I did the work done on the system or work done by the system. What I did, work done on the system or work done by the system. On the system, on only. See, this is my system. We has applied the pressure, right? We has applied the external pressure, means now the system has been compressed. So on the pressure, right? Now work done. Work done. Work done is equal to, can I say P minus P external delta V? Can I say why this minus has been came? Now let's suppose for initially for my system volume is 10 ml. When I was compressed this one, now V2 has been reached to the 5 ml. Means change in volume will be minus P external 5 minus 10. 5 minus work done will be the P external delta V, right? Work done will be the P external delta V. Now the delta V will be V2 minus V1. V2 minus V1, 5 minus 10. That it will give entire value, it will give the negative, right? So can I say work done? Work done is equal to minus P external delta V. Minus P external delta V. This is a work done formula. Work done formula. Next, for the same formula, we can say it as a dW, work done, is equal to minus P external V1 to V2, P external minus P external delta V. Now these are the work done formulas we have to remember. This is the work done formula. What is the work done formula? Integration V1 to V2 P external delta V, or work done is equal to minus P external delta V. Now this is a work done formula. Right. Next we are going to see the units for the energy or work. This will play, my dear friends, this will play very crucial role. Units of energy or work. Okay. See, now whatever may be the units I was explaining, based on this units only. April 3, 2025, same. April 3, 2025, same JEE mains question. They have asked only which was the units I was explaining and the work done formula. So I will give that question also. Now first listen to the units. 1 joule is equal to 10 to the power 7 ergs. Okay. Now next one. 1 joule is equal to 1 by 4.184 calories. Okay. 1 calorie is equal to 4.2 joules. Right. Next one. Next one, very beautiful formula that we are having, or that we know, R is equal to 0.0821 atm liter per Kelvin mole. Next, R value we are having 8.314 joule per Kelvin mole. Now these are the two universal gas constant values we are having. Now when we are equating this, both the universal gas constant value 0.0821 atm liter per Kelvin mole is equal to 8.314 joule per Kelvin mole. Now you can see Kelvin mole get cancelled. Now if you take the 0.0821 to the left hand side, 1 atm liter will be equal to 8.314 by 0.0821 joules. That it will be directly, it will be given the 1 liter atm will be equal to 101.2 joules. 101.2 joules means Here this will play very crucial role. Now work done formula, work done is equal to minus P external delta V. Now pressure is a ATM, volume is a liter, but they will ask you to calculate the work done in the joules. They will ask you to work done in the joules, means then you have to multiply 101.2 joules. If you multiply that, you will get the answer. Okay, this is a 1 ATM liter. Let's suppose if they ask in the calories, 1 ATM liter is equal to 24.2 calories. This is also one very key point you have to remember. In the calories, if they ask 24.2 calories, okay, in the joules, if they ask 101.2 joules, now this is a clear. Work done formula clear, units clear. Now I will give you the question which they was asked on the JEE mains 2025. Now, one P versus V graph they have given. One P versus V graph they have given. Okay. Now, initially this volume is 1000 and this volume is 2000 per centimeter cube. Okay. Now here this pressure is 1 ATM and this pressure is 3 ATM. From the starting from 1 it has reached to the 2, from the 2 it has reached to the 3, from the 3 it has reached to the 4. So the question is asking, while going from the point 1 to point 4, what is the work done in joules? What is the work done in joules from point 1 to point 4? When the system is going from the point 1 to point 4, what is the work done? It has happened. What is the work done? It has happened. Now this is the ATM. What is the work done? It has happened. Work done in joules is asking. 303.6 joules. Yes. Good, Pranit, good. Now here you can see from the point 1 to point 2. Actually this is April 3 2025 question, JEE mains. Now you can see here from the point 1 to point 2, volume is constant. If the volume is constant, work done is equal to minus P external delta V. If the volume is constant, work done is constant. From the 3 to 4 also volume is constant, so work done is constant. So only we have to calculate the work done in the 2 to 3. Work done in the 2 to 3, volume is increasing from the 1000 to 2000. So the change in volume will be, how much? Work done will be equal to the minus 3, change in the volume will be 1000. But he has given the unit also will play very crucial role. Here they have given on the basis of ml. 1 ml will be equal to the 1 ml. If you convert the centimeter cube into the liter, because 1 ATM liter, but unit they have given centimeter. So if you convert that into the centimeter into the liter, then it will become, this is 3 ATM and this will become liter. 1000 get cancelled. W will be equal to minus 3 ATM liter. But is asking in the joule, right? Minus 3 into 101.2 joules. If you calculate, minus 303.6 joules. This is the answer. This is the same question they have asked in the April 3 2025 question they asked. Next one beautiful question I will ask you. You have to say me the answer. Now, I will write the equation. Now you have to say me the answer. H2O liquid, when it is converting into the H2O gas, work done on the system or by the system? For this one, work done on the system or by the system? Work done on the system or by the system? H2O liquid converting into, right, work done by the system because volume is increasing. Good, right, volume is increasing, work done by the system. Second, H2O solid converting into H2O liquid at a 0 degrees Celsius. Now, work done on the system or work done by the system? Let's take 4 degrees Celsius. 2 degrees Celsius will take better. Better will take the 0 degrees Celsius on. Why to get confused? Work done by the system or work done on the system? First one is a work done by the system. Second one, work done on the system. Why work done on the system? Here also volume is increasing, right? No. My question is, here you are saying liquid is converting into the gas, volume is increasing, so you are saying it as a work done by the system. So here also solid, when it is converting into the liquid, then volume is increasing, right? But then it should be the work done by the system. Why you are saying work done on the system? That is my question. Sir, first it will compress, I think, then expand. How come compress? No compression. How come compression will be happen? But that is not the exact answer which you are, reason you are not giving. Work done on the system is correct only. For that one I will accept. Good. Melting point is also one key point, but exact reason you are not saying. I explained very clearly this reason also. Why only it is work done on the system? Melting point is not the key criteria. One key criteria will be there. Ice float on the liquid. Okay. So that if ice float on the liquid, but ice is solid only, no. నా క్వశ్చన్ ఏంటంటే, ఇప్పుడు ఐస్ అనేది సాలిడ్ లో వాల్యూమ్ తక్కువ, ఇప్పుడు అది లిక్విడ్ లో కన్వర్ట్ అవుతున్నప్పుడు వాల్యూమ్ ఎక్కువ. మరి వాల్యూమ్ ఎక్కువ అన్నప్పుడు గుడ్ సూరజ్, గుడ్. సో when the H2O solid, when it has been formed, it will form the 4 hydrogen bondings. When it is forming the 4 hydrogen bondings, its volume will be high. When its volume will be high. Now you can see, when it is forming the 4 hydrogen bondings, its volume is high. Clear? Now, when its volume is high, when it is converting into the liquid, it will break its hydrogen bonding. When its hydrogen bonding is breaking, its volume is decreasing. When its volume is decreasing means it will be work done on the system. This is a very important example. You have to be very careful. H2O at 0 degree, it will form the 4 hydrogen bondings. Now it will break that hydrogen bondings. As the hydrogen bondings it will be break, its volume will be what? Its volume will be decreases. Its volume will be decreases. In the class also I explained very clearly. So this is work done on the system. Okay, right. Next. Next directly we'll moving to the first law of thermodynamics. Now what is the meaning of the first law of thermodynamics? Here for the first law of the thermodynamics, what I was taking the one system. This is one system. This is our system. Okay. Now for my system, this is our internal energy. This system internal energy I will change with the two parameters. What are the two parameters I will change this system? First, I will change this system internal energy. Every system is having some internal energy, right? I will change this system internal energy by supplying heat. Wherever supplying the heat to the system internal energy, obviously it will be changed, because this gas will absorb some energy. Due to that energy it will move very fastly. Internal energy of the system has been disturbed. Now my internal energy of my system has been disturbed due to the supplying of the heat. Okay. Now next I was changing my system internal energy through the work. Now I was changing my system internal energy through the work. So my system internal energy I was changed through the work by compressing. I was changed. Now this is my final internal energy. Now final internal energy, this is my system internal energy. System internal energy I was changed with the heat and I was changed with the work, and it has reached to the final internal energy. Here initial internal energy, let's suppose it is having the 100 kilojoule, means finally it has reached to the 500 kilojoule, let us assume. Then if I send this U1 to the left hand side, U2 minus U1 is equal to Q plus W. Now this is called as a change in internal energy, and this is a first law of thermodynamics formula. My dear friends, in the physics and in the chemistry, this is the only difference we are having. In our chemistry, the first law of thermodynamics formula is internal energy Q plus W. Internal energy Q plus W. Here work done on the system or work done by the system. Now in the third process, my internal energy system I was changed by work done by the system I was changed, work done on the system I was changed. Work done by చేసిన on చేసిన ఈ సిస్టమ్ యొక్క ఇంటర్నల్ ఎనర్జీ ఆన్ ద సిస్టమ్ చేసిన కదా, సో ఇది పాజిటివ్. వర్క్ డన్ బై ద సిస్టమ్ ఈజ్ పాజిటివ్, రైట్? బట్ వర్క్ డన్ బై ద సిస్టమ్ ఈజ్ పాజిటివ్, బట్ ఇన్ ద ఫిజిక్స్ వర్క్ డన్ ఆన్ ద సిస్టమ్ ఇట్ ఈస్ నెగటివ్. వర్క్ డన్ బై ద సిస్టమ్ ఇన్ అవర్ కెమిస్ట్రీ ఇట్ ఈస్ నెగటివ్, బట్ ఇన్ ద ఫిజిక్స్ ఇట్ ఈస్ పాజిటివ్. Okay, this is the first law of thermodynamics formula. Change in internal energy is equal to Q plus W. This is the first law of thermodynamics formula, right? Now based on this one, now we are going to interrelate these formulas. This first law of thermodynamics formulas we have to interrelate with the thermodynamic process. Now listen, this will play very crucial role. First law of thermodynamic process, first we have to relate with the isothermal process. For the isothermal process, which is constant? Temperature is constant, right? Temperature is constant. If the temperature is constant, thermodynamic formula, first law according to the FLTD, Thermodynamic parameter, temperature is constant, FLTD formula, Q internal energy is equal to Q plus W. If the internal energy is equal to Q plus W means temperature constant, means according to the FLTG, which parameter is constant and why it is constant? Which parameter is constant, why it is constant? Which parameter is constant, why it is constant? According to the FLTD, internal energy is constant. Why? The temperature is constant, right? So that's the reason in the starting itself I was written very clearly I explained internal energy will be depend upon the temperature. Internal energy will be depend upon the temperature. This is the one key point I was written. You can see here that key point it has been utilized. See, internal energy is depending upon the temperature. If the internal energy, if it is depending upon the temperature, means here temperature constant according to the FLTD, internal change in internal energy will become 0. The change in internal energy, if it is become 0, means Q is equal to minus W. What does it mean? So what does it mean? If Q is equal to minus W means what does it mean? Means what it is saying, the amount of heat supplied to the system, is utilized to do mechanical work. Now this is, it is saying all the heat is utilized in the work. Good. Right. Next process we are having, second process we are having adiabatic process. Adiabatic process we know Q is constant. If the Q is constant, now according to the FLTD, Q plus W. Q means W means internal energy will be equal to W. Means what it is saying, system, what it is saying, at the constant heat, system is having some internal energy. System utilized some internal energy, or system utilized internal energy to do work. Next, third one, isocoric process. In the isocoric process, which is constant? Volume is constant. Means du is equal to Q plus W. Now W is equal to minus P external dV. If volume is constant means W is constant. Means heat. Now what it is saying, the heat supplied at a constant volume, system increasing its internal energy. Next one, before going to the isocoric process, I want to introduce one new thermodynamic parameter, that is a enthalpy H. Why I was introducing this enthalpy means, you can see whatever may be the heat I was supplying at constant volume, that it is utilizing to increase the system internal energy. Now if I want to supply heat to make the constant volume, system should be rigid, means that system's wall should be rigid, then only the volume will be constant. But I don't want to keep the system volume constant. Means if I don't want to keep the system volume constant, means I was to take the open container. If I was taking the open container, now when I was applying the heat, whatever may be the heat it is exchanging, I want to calculate. Then that type of the parameter we call it as a enthalpy. Here which parameter is not constant? Volume is not constant, but one parameter it is constant. That parameter we call it as a constant pressure. Means what is the meaning of the enthalpy? Means heat content of the system, measured at constant pressure and temperature is called enthalpy. That it is represented by the H. See, if you make it as a closed container, then we call it as a internal energy. But I don't want to make the constant volume. So what the parameter I made? Constant pressure. If I made the constant pressure, then we can say it as a enthalpy. So enthalpy H is equal to E plus PV. Now this is the formula of the enthalpy. Now here also enthalpy is also one state function. Because exact value of enthalpy cannot be calculated. Only change in enthalpy only can be calculated. Only change in enthalpy. Next, it is extensive property. So change in enthalpy only can be calculated. Done. Now this is a one enthalpy parameter it has been came. Now based on this enthalpy parameter, now how the isobaric process will be there, now we'll see. Isobaric process. Now the isobaric process, how it will work, now we'll see. Now in this isobaric process, which is constant? Pressure is constant, right? Now in this pressure, according to the FLTD, we know internal energy at a constant pressure. Now volume work done formula, work done will be equal to minus P external V2 minus V1, right? Now plus W, that it will become minus P V2 minus V1, right? Now this I can write it as a, can I write change in internal energy will be U2 minus U1 is equal to QP minus PV2 plus PV1. Done. Now if I send it to the left hand side, U2 plus PV2 minus U1 plus PV1, can I write, is equal to QP. Can I write this one? Now here this formula will be relating to the internal energy, right? Here the E we can write, U we can write, don't get confused. Now this is relating to the internal energy H2 and this is relating to the internal energy H1, that it will be equal to the QP. Now this is H2 minus H1 will be the change in enthalpy. Means here it is saying that whatever may be the heat we have supplied at the constant pressure, that it is utilizing to increase the system enthalpy. What it is saying, it is utilizing to increase the system enthalpy. These are the four formulas we are. Now you say me, isothermal process, what is the FLTD formula? Isothermal process, what is the FLTD formula? Fast. In the isothermal, what is the FLTD formula? Adiabatic, what is the FLTD formula? Isochoric, what is the formula? And isobaric, what is the formula? Isothermal is equal to Q is equal to minus W. Adiabatic, U is equal to W. Change in internal energy will be equal to work done. Isochoric, change in internal energy will be supplied, volume supplied. Yes, yes. Now enthalpy at constant volume. Now these are the formulas we have to remember. Now these are the formulas we have to remember, right? Now these are the FLTD formulas. Now based on these formulas, the next concept we are going to study, that is a molar heat capacity. Molar heat capacity. So heat capacity, specific heat capacity and the molar heat capacity we have studied. Specific heat capacity we have studied. Now we are going to study about the molar heat capacity. My dear friends, only one thing you have to remember. If you have seen word molar heat capacity, the word molar, if you have seen, that indicates comes under the intensive property. Molar means one mole, 1 molar. What is the meaning of the molar heat capacity? Means the heat required to raise the temperature of 1 mole of substance through 1 degree. 1 mole of substance to 1 degree is known as a molar heat capacity. So this is a cm. Molar heat capacity will be represented by the cm. Now this molar heat capacity cv, molar heat capacity cp. What is the meaning of the molar heat capacity? Molar heat capacity formula will be equal to heat capacity by number of moles. Now molar heat capacity at the constant volume, molar heat capacity at the constant pressure. Now we'll see. Molar heat capacity will comes under the extensive property or intensive property. Means it will comes under the intensive property. Sir, how it will comes under the intensive property, sir? Now I will explain. Listen. I was taking the 10 mole of substance. ఈ 10 mole of substance ని హీట్ చేయడానికి నాకు ఒక 100 kilojoules of energy కావాలి. ఈ 10 mole కాస్త ఈ 10 mole అని చేయకుండా ఒక 5 mole of a substance తీసుకుంటా. ఇప్పుడు ఈ 5 moles substance ని హీట్ చేయడానికి నాకు 50 kilojoules of energy కావాలి. అయితే ఈ 10 moles అని అంటే నేను మాస్ చేంజ్ చేస్తున్నా కొద్దీ హీట్ కెపాసిటీ అనేది చేంజ్ అయిపోతుంది. అంటే హీట్ కెపాసిటీ అనేది మాస్ మీద డిపెండ్ అవుతుంది కాబట్టి అది ఎక్స్టెన్సివ్. ఇప్పుడు ఈ 10 mole అనే సబ్స్టాన్స్ లో నుంచి ఒక 1 mole తీస్తా. 1 mole తీసి ఈ 1 mole కి ఎంత హీట్ కావాలి అని నేను క్యాలిక్యులేట్ చేస్తే నాకు వచ్చింది 10 kilojoules వచ్చింది. అయిపోయింది. ఇప్పుడు ఈ 5 moles లో నుంచి కూడా ఒక మోల్ తీస్తా. ఒక మోల్ తీసి దీనికి ఎంత హీట్ కావాలి అని నేను క్యాలిక్యులేట్ చేస్తే నాకు వచ్చింది ఎంత 10 kilojoules. అంటే ఇప్పుడు నేను మాస్ చేంజ్ చేసిన తర్వాత కూడా దాంట్లో నుంచి ఒక 1 mole కి నేను ఎంత హీట్ కావాలో నేను చెక్ చేస్తే నాకు రెండు సైడ్లో సేమ్ 10 kilojoules వచ్చింది కదా. రెండు సైడ్లలో అంటే నేను మాస్ చేంజ్ చేసిన తర్వాత కూడా మోలార్ హీట్ కెపాసిటీ ఎంత కావాలి? వాడు 1 mole కే కదా అడిగేది. 1 mole కే అడుగుతున్నాడు కాబట్టి మరి నేను డిఫరెంట్ మాసెస్లో నుంచి ఒక్కొక్క మోల్ తీసుకొని హీట్ కెపాసిటీ చెక్ చేస్తే నాకు 10 kilojoules వచ్చింది, 10 kilojoules వచ్చింది. అంటే దాని హీట్ కెపాసిటీ ఫర్ 1 mole కి ఫిక్స్డ్ కదా. మరి ఫిక్స్డ్ ప్రాపర్టీస్ విల్ కమ్స్ అండర్కి ఎక్కడికి వస్తాయి? ఇంటెన్సివ్ ప్రాపర్టీకి వస్తాయి. ఐ హోప్ ఇట్ ఈస్ క్లియరా? అర్థమైందా? అర్థమైందా? Or still you are having any doubts? I hope it is clear. No. Yes. Right. Now we'll see the molar heat capacity at constant volume. Molar heat capacity at constant volume. Molar heat capacity at constant volume formula will be equal to heat capacity by number of moles. Heat capacity formula in the heat by number of moles into change in temperature. Right? Now, according to the FLTD, constant volume, whatever may be the heat we have supplied, that it will be equal to the change in internal energy kada. Just now we have seen isochloric process lo volume constant daggara edaithe heat supply chesnamo, that it will be equal to internal energy. Means, can I say in the presence of QV, can I write M internal energy, N delta T. So if I take it to the left hand side, one very beautiful formula we got. Now change in internal energy will be equal to NCV delta T. This is a one very beautiful formula and very important formula. Based on this formula we are having the n number of questions. The formula chala important. So CV is equal to delta U NCV delta T. For a small change, NCV dt. This is for the small change. This is CV formula. Now, CP formula, if they ask, CP is equal to QP by N delta T. Right? Now, according to the FLTD, at constant pressure, it will be equal to the enthalpy. Now, CP is equal to delta H by N delta T. Right? Now, delta H is equal to NCP delta T. Now, delta H is equal to NCP dt. Delta H is equal to NCP dt. Right? Now, this is a CP and a CV formula we got. Now, we are going to study the relation between the CP and CV. Relation between CP and CV. Now, what is the relation between the CP and CV? Now, at a constant pressure, we know enthalpy will be equal to internal energy plus PV. This is a formula we are having. For 1 mole, PV is equal to RT, ideal gas formula. Then in the place of PV, if I substitute RT, then H is equal to U plus RT. Now, this is a equation 1, let us do. Differentiate equation 1 with respect to T. Then it will become dH by dt, du by dt plus R. Now we know dH by dt and du by dt. You can see here for the 1 mole, CP will be equal to dH by dt. Now CV will be equal to, for 1 mole, du by dt for n is equal to 1. Now here also for n is equal to 1. Then can I say this formula CP is equal to CV plus R. Then if I send the CV to the left hand side, CP minus CV is equal to R. This is for the n moles. This is for the n moles. Now CP minus CV is equal to R. Now next concept we are having Poisson's ratio. Now the next one we are having the Poisson's ratio. Now Poisson's ratio is equal to gamma. Now my dear friends, that CP, CV uh, directly I will give the derivation. It is not at all required for our JEE JEE mains, so I was not giving any direct derivation. Just you remember which it is important for our thermodynamics, that only I will explain. Derivation part I was not going because it is waste of time also. Now the Poisson's ratio gamma is equal to Cp by Cv. Cp by Cv. I don't know, Suraj, I too don't know when the class will end. But today I will finish. Today thermodynamics I will finish. It may be 1 or it may be 2 or it may be 11 or it may be 12. I think so max it will take 11:30 to 1. Max 1 it will take. 1 a.m. or 1:30 a.m. it will take max. Okay. Right. Today I will finish because this will be helpful for us and it may be for the reference for the upcoming the students who want to learn also. It will be a reference for them. So if it is in the one shot video, it will be also helpful for the others also. First, let me complete the first law of thermodynamics questions. Better, it's almost 2.5 hours, right? Let me take the break. Half an hour break I will take, and at 10 o'clock exactly I will start. Means this live will be in the same, it will be continuation only. So 30 minutes. Yes. 30 minutes break will take. Exactly 10 p.m. will start. 10 p.m. will start the class. Okay. Now have the dinner and come. తర్వాత మళ్ళా 2.5 hours తర్వాత మళ్ళీ ఒక బ్రేక్ తీసుకుందాం. ఓకే ఫైన్. నానా నిద్ర వస్తే పడుకో నానా. నీకు చదువుకోవాలి అని ఇంట్రెస్ట్ ఉంటే చదువుకో, పడుకోవాలని ఇంట్రెస్ట్ ఉంటే పడుకో. Hello, hello, my dear friends. Anyone is in live? Now you can decide by your own, my dear friends. Now, anyone is in live? If anyone is in the live, once say me hi. Uh, G sir, it's a 12th. I have given the physics chemistry exam, but other exam dates are out at. The results take at least 2 months. Can I still prepare? You can prepare for the JEE. Yes, yes. Subhana is in the live and the noob is in the live. Okay, I was turning off my camera just with the without camera. Just I was going to start the class. If you are having any doubts, if you are having any, if any voice is clear, right? Yes, you can prepare for the JEE 2026. No problem. You can write. And your age is 21. But JEE eligibility, we have to cross check. You can prepare, Nana. Don't. No. Now, shall we start our lecture? Once now the voice and everything is clear, right? Done. Right. Now the next, the Poisson's ratio, we are having the gamma is equal to Cp by Cv, right? Now, next year about this gamma, directly I was giving the gamma values for the monoatomic gas, diatomic gas and the triatomic gas. No need of remembering any derivations and all. But how this gamma values it has came, now I will say. First one for the monoatomic gas, if I spend the time on one topic, it will take more time. For the monoatomic gas, if I want to calculate the CV is equal to E by 2 R. This is the formula for the CV. Now CP minus CV is equal to R, we know. Now the CP formula will be equal to CV plus R. Now this is the formula. Now what is the E here? Now what is the E here means E is equal to degree of freedom. E is nothing but degree of freedom. This degree of freedom will be calculated on the basis of translational plus rotational plus vibrational. But this vibrational will be considered at the higher temperature. So as per that, we are not considering vibrational. Not considering. Only translational plus rotational we will consider. Now for the monoatomic gases means nothing but noble gases. Noble gases will comes under the which one? Monoatomic gases. Example helium, neon, argon. Now translational degree of freedom for any gases will be 3. And the rotational degree of freedom for the monoatomic gas will be 0. Then CV will be equal to 3 by 2 R. Then CP will be equal to 5 by 2 R. Then gamma will be equal to for the monoatomic gas. Gamma will be equal to what is the gamma formula? Poisson's ratio gamma is equal to Cp by Cv. Cv is equal to 3 by 2 R. Then it will become 5 by 3. 5 by 3 will be equal to 1.66. For the monoatomic gas, the gamma value will be 1.66. That you have to remember. Next, diatomic gas. Diatomic gas. For the diatomic gas, now Cv will be equal to E, degree of freedom. E will be equal to 3 plus 2. My dear friends, if you are getting confusion, sir, for the monoatomic gas, translational degree of freedom you have taken the 0. But diatomic gas, translational degree of freedom you have taken the 3. But, this is rotational degree of freedom you have taken 2. How? How means here, now I will say about the rotation and spin. Rotation and the spin is different. Now this is the sun. Let's suppose this is the sun. Sun will rotate around the sun. Earth will rotate around the sun. Earth will spin around the sun. Cheppanada. This is sun and this is earth. Earth rotate chestada, sun ki around rotate chestada, spin chestada. Earth is rotating or spinning. ఇది ఒక్కటి క్లియర్ అయితే ఎర్త్ ఈస్ రొటేటింగ్. మరి ఫ్యాన్ ఈస్ రొటేటింగ్ ఆర్ స్పిన్నింగ్? ఫ్యాన్ ఈస్ రొటేటింగ్ ఆర్ స్పిన్నింగ్? ఫ్యాన్ రొటేట్ అవుతుందా స్పిన్ అవుతుందా? ఫ్యాన్ ఈస్ రొటేటింగ్ ఆర్ స్పిన్నింగ్? ఫ్యాన్ ఈస్ స్పిన్నింగ్. అంటే రొటేషనల్ డిగ్రీ ఆఫ్ ఫ్రీడమ్ ని కన్సిడర్ చేయాలి అని అంటే ఆన్ ఇట్స్ ఓన్ యాక్సిస్. ఇప్పుడు దిస్ ఈస్ 3 axis, right? This is x axis, y axis and the z axis. Now when a monoatomic gas, it can translate to the x axis, y axis and the z axis. So its a translational degree of freedom is 3 for the monoatomic gas. మరి అదే rotational తీసుకుంటే for a monoatomic gas, if I consider the monoatomic gas, for the monoatomic gas on its own axis it is spinning, not rotating. But here the degree of freedom we are considering rotation, right? On its own axis it will rotate. On its own axis it will spin, not rotate. You have to be very careful. This is the external axis. Now fan will spin on its own axis. For that bearing, what it is there, it will be spin, it will not rotate. So when the gas is rotating, for the monoatomic gas on its own axis, it will be spin. That's the reason rotational degree of freedom is 0. But for the diatomic gas, on its own axis, it will be spin, and for the other axis, it will be rotate. See, when it is rotating like this, it is touching the, let's suppose this is x, this is y, and this is z. It is touching the x axis and the z axis, right? So its rotational degree of freedom is 2. On its own axis, it will be spin. When it is touching the other axis, it is rotating. That you have to be very careful, and you have to be very clear with the rotation and the spin. We are considering rotational degree of freedom, not the spin degree of freedom. So for the diatomic gas, translational 2, 3, rotation 2. Then CV will be then CV will be 5 by 2 R. Then CP will be 7 by 2 R. Then gamma will be equal to 7 by 5, that it will be equal to 1.44. Next, for the triatomic gas, then degree of freedom, translational 3, rotational 3. Then it will become 6. Then CV will be equal to 3R, CP will be equal to 4R. Right? Now the gamma value will be equal to 1.33. 1.33. Now here the gamma value for the diatomic will be 1.44. And the gamma value for the monoatomic gas will be 1.66. These values will play very, very crucial role in identification of the diatomic and the adiabatic process, and the next one isothermal process it will play. Right. So these are the diatomic gas and the triatomic gas. Now we to know. Now I was deriving the formulas for the work done. From now onwards, after deriving the formula, I will 1.4, okay, 1.40, okay, 1.4, sorry, yes, right, 1.4, 1.33, right. Now, these are the, now we are going to derive the work done formulas in the reversible and irreversible. Work done formulas based after deriving the work done formulas in the reversible and in the irreversible process. I will do the n number of questions. My dear friends, be ready with your pen, but don't do the calculation in the calculator. Okay? Done? Now, first we are going to derive the formula work done in a reversible process, work done in the reversible process of isothermal ideal gas. Means for the ideal gas in the isothermal reversible work done when it has been done. Now what is the formula? Isothermal reversible expansion and the compression of ideal gas in isothermal process. What is the work done formula we'll get? Now we'll see. Let's suppose in the reversible process, A is converting into B. If A is converting into the B, now I require 100 kilojoules of energy. Then again B to convert into the A, I require same energy or different energy. See, in the reversible process is a slow process, and each step P external gas will be equal to the P gas, we know, right? Then Same if the A is converting into the B. See, now this is a gas. ఇప్పుడు ఇది గ్యాస్ అమ్మా. ఇప్పుడు ఇది గ్యాస్ కదా. ఇప్పుడు ఈ గ్యాస్కి చిన్న స్టోన్ వేసి వాల్యూమ్ చేంజ్ చేసిన. అదెంత 10 ml. 10 ml ఉండాల్సిన వాల్యూమ్ ఎంత అయిపోయింది? 9.999999 ml అయింది కదా. మరి ఇప్పుడు ఈ స్టోన్ని నేను తీసేస్తా. ఈ స్టోన్ని నేను తీసేసిన తర్వాత ఏమైపోతుంది? ఈ పిస్టన్ మళ్ళీ చేంజ్ అయ్యి 10 mlకి వచ్చేస్తుంది కదా. అంటే ఏని బీలో కన్వర్ట్ చేయడానికి 100 kilojoules ఆఫ్ ఎనర్జీ అయితే మళ్ళీ సేమ్ బీని ఏలో కన్వర్ట్ చేయడానికి అంటే సేమ్ 100 kilojoules ఆఫ్ ఎనర్జీ కదా కావాల్సింది. అంటే ఇక్కడ పి ఎక్స్టర్నల్ విల్ బి ఈక్వల్ టు ద పి గ్యాస్ అని అర్థం. ఇందులో రివర్సబుల్ ప్రాసెస్లో దిస్ ఇస్ ద ఫస్ట్ కీ స్టెప్ యూ హ్యావ్ టు రిమెంబర్. ఓకేనా? ఇక్కడ మనం వర్క్ డన్ ఫర్ ద విచ్ గ్యాస్ కి మాట్లాడుతున్నాం? ఐడియల్ గ్యాస్ కి కదా. వీఆర్ టాకింగ్ అబౌట్ ద ఐడియల్ గ్యాస్, రైట్? వర్క్ డన్ ఇన్ ద రివర్సబుల్ ప్రాసెస్. వర్క్ డన్ ఇన్ ద రివర్సబుల్ ప్రాసెస్ లో ఇక్కడ విచ్ ఈస్ నాట్ కాన్స్టెంట్, పి ఎక్స్టర్నల్ కాన్స్టెంట్ కాదు కదా. వర్క్ డన్ ఫార్ములా ఏంది? వర్క్ డన్ ఈజ్ ఈక్వల్ టు మైనస్ పి ఎక్స్టర్నల్ ఫ్రమ్ ద V1 to V2 పి ఎక్స్టర్నల్ డివి ఫార్ములా వర్క్ డన్ మనకుంది. కాకపోతే వీఆర్ డీలింగ్ ద ఐడియల్ గ్యాస్ కదా. ఐడియల్ గ్యాస్ ఫార్ములా ఏంది? పి గ్యాస్ వి ఈజ్ ఈక్వల్ టు ఎన్ఆర్టీ కదా. ఇప్పుడు వీని లెఫ్ట్ హ్యాండ్ సైడ్ తీసుకెళ్తే పి గ్యాస్ విల్ బి ఈక్వల్ టు ఎన్ఆర్టీ బై వి అని రాయొచ్చు కదా నేను. అంటే ఇప్పుడు పి ఎక్స్టర్నల్ ఇన్ ద రివర్సబుల్ ప్రాసెస్లో పి ఎక్స్టర్నల్ గ్యాస్ విల్ బి ఈక్వల్ టు పి గ్యాస్ అంటే మరి ఇన్ ది ప్లేస్ ఆఫ్ పి ఎక్స్టర్నల్ కెన్ ఐ రైట్ ఇట్ యాజ్ అ పి గ్యాస్ మైనస్ V1 to V2 పి గ్యాస్ డివి కెన్ ఐ రైట్? ఇక్కడ అర్థమైంది కదమ్మా. పి ఎక్స్టర్నల్ ఈజ్ ఆల్మోస్ట్ ఈక్వల్ టు ద పి గ్యాస్. వీఆర్ డిరైవింగ్ ఫర్ ద ఐడియల్ గ్యాస్ కదా. మరి పి ఎక్స్టర్నల్ గ్యాస్ కి పి గ్యాస్ అని రీప్లేస్ చేసుకోవచ్చు కదా. పి గ్యాస్ ఫార్ములా ఎన్ఆర్టీ కదా. దెన్ వీ కెన్ రైట్ W ఈజ్ ఈక్వల్ టు మైనస్ ఎక్స్టర్నల్ V1 to V2 ఎన్ఆర్టీ డివి బై వి ఇట్లా రాసుకోవచ్చు కదా. ఇక్కడ ఎన్ఆర్టీ ఈజ్ కామన్, ఎన్ఆర్టీ ఈజ్ కాన్స్టెంట్. ఎన్ఆర్టీని ఇంటిగ్రేషన్ అవుట్ సైడ్ కి తీసుకొస్తే వాట్ ఇట్ విల్ బికమ్? W ఈజ్ ఈక్వల్ టు మైనస్ ఎన్ఆర్టీ ఇంటిగ్రేషన్ V1 to V2 1 by V dV. 1 by V dV. Now 1 by V dV. Now what is the integration x1 to x2 1 by x dx. What is the formula? Integration x1 to limit x1 to x2 1 by x dx. What is the formula? log x ln x. log x కాదనుకో ln x. ఇంటిగ్రేషన్ x1 to x2 1 by x dx will be equal to ln x. Now it will be equal to the ln x. After the ln x, if you apply the limits, then it will become minus log base e. log base e will become ln x. Right. Okay. Now then nrt after applying the natural log limit ln v2 minus ln, then directly I was writing this is the ln v upper limit v1 to v2, then ln limit if you apply, then the work done formula will become W is equal to minus nRT ln v2 by v1. This is in the form of the natural log. If you want to convert, this is in the form of the ln. If you want to convert into the log, then it will become minus 2.303 nRT log base 10. This is very, very important. Log base 10 v2 by v1. Now this is a work done in the reversible process formula. This is the work done reversible process formula. Okay. Now, the same formula, sometimes they may change it with the, which one? They may change with the pressure, or they may ask with the pressure. If suppose they may ask with the pressure, how to change into the pressure? According to the ideal gas, we know PV is equal to nRT. Clear? Now, P1 V1 is equal to P2 V2 according to the Boyle's law. Now, then it will become, what it will become? V2 by V1 is equal to P1 by P2. Then the work done in the reversible process for the pressure, the formula will be changes to 2.303 nRT log base 10 P1 by P2. Now, these are the two beautiful formulas we are having for the work done in the reversible process. Work done in the reversible process, we are having these two formulas. These are the two formulas we are having. Okay. Now, this is a work done for the expansion and the compression we are having. Now, next same formula we are going to derive isothermal irreversible expansion or compression of ideal gas. Now, of ideal gas. Now I was deriving the formula of the work done of isothermal irreversible expansion and compression. Now you see, let's suppose to convert A into B, I require 90 kilojoules of energy. Then again this B to convert into A, I require same energy or more than. See, I was converted A into B with the 90 kilojoules of energy. Again this B to convert into A, I require more than 90 kilojoules of energy or less than 90 kilojoules of energy. Or same energy I can do. With the same energy, can I change the system into, can I reverse the system with the same energy? Can I change the system? Can I change the system with the same energy? With the same energy, can I restore the system? I require more energy because irreversible process, right? Irreversible process will be happen very single step. Very fastly it will be happen. Very fastly when it has happened, when I was thrown the stone to this system, again to make water. Best example I will take for the irreversible process. If the water it is coming from the uphill to the downhill, okay? Waterfall, let's take. Water it is coming from the uphill to the downhill here. Again I want to make this water to flow back to the uphill. Now what I have to do? I was to supply some energy, right? No, I was to supply some energy. When I supply some energy to this one, what it will be happen? Now again this water will be restored back. Means when the 90 kilojoules of energy it has required to convert A to B, now again B to convert into the A, I require more energy, right? More energy. And in the one very beautiful starting in the reversible and irreversible, when I was explaining, I explained one thing. What? P external will be equal to the final pressure in the irreversible process. Means whatever may be the work done, it has been happened in the irreversible process, that it will be happened against the constant external pressure. Means against the constant external pressure only it has been happened, and that constant external pressure will be equal to the P2. My dear friends, whenever in the question, if suppose P external, if they have not given, that indicates that is the final pressure. So In the irreversible process, work done is happen against the constant external pressure kada. Constant external pressure work has been done in the irreversible process. Now we'll see the work done formula. Now how the work done formula will get, now we see. Here work done formula is equal to minus P external integration V1 to V2 dV. Can I write? This can I write? Because in the irreversible process, it has happened against the constant external pressure, right? So this constant I was brought it from the integration, out of the integration. So here P external will be equal to the final pressure. So in the place of P external, can I write work done will be equal to minus P2 integration V1 by V2 dV. V1 by V2 dV. Now integration x1 to x2 dx. Now that we can write it as a work done in the irreversible process will be equal to minus P2 V2 minus V1. Now this is a work done formula in a irreversible process. Work done formula in irreversible process. Now here x integration x1 to x integration limit from x1 to x2 dx will be equal to the x2 minus x1. x2 minus x1. The same way this is also in the form of the v1 to v2 dv, that it will give you the v2 minus v1. Now if you want to expand this formula, work done in the irreversible, now we are dealing with the ideal gas, right? Ideal gas formula PV is equal to nRT. PV is equal to nRT. If you send the V to the left hand side, P is equal to nRT by V. nRT by V. Then we can expand this formula in this manner. Here P2 by V2 minus V1. Now in the place of V1, so okay, better we'll change the V. Now in the place of the V, I was substituting the nRT by P. Now here the N is constant, R is constant, T is constant. Only the pressure is changing, right? If it is a V2, it will become P2. If it is a V1, nRT P1. Now work done irreversible will be equal to P2 into nRT by P2 minus nRT by V1. Now this nRT is constant. P2 if I was sending into the square bracket, then it will be happen nRT P2 by P2 by this is P1. Now P2 by P1. P2 by P2 by P2 it will be get cancelled. Then it will become 1. Work done in the irreversible process will be equal to minus. Now minus nRT 1 minus P2 by P1. Now this is a work done formula in the irreversible process. This is a work done formula in the irreversible process. Now you see, work done in the reversible process, work done is different, and work done in the irreversible process, now the formula is different. So in the both the cases, formula it is different. Work done in the irreversible process, formula is different. Work done in the reversible process, different. So which work done formula I was to use, sir? I was not getting, means I was said, right? What? If in the question, if you see the constant external pressure, if you see the constant external pressure blindly, without any doubt, you just use this formula and solve. Okay. Next one. Irreversible free expansion or gas or vacuum. This is also one very beautiful unnecessary data they will dump in the question, and at the end they will give you one word. What? Free expansion. Free expansion of gas or vacuum, if you have seen in the question. Free expansion or vacuum, if you have seen in the question, Now, hello, hello, sing hello. Now, if you have seen this free expansion or vacuum in the question, just this free expansion of the gas will be happen. See, this gas is want to expand. If this gas want to expand means, if external pressure, if it is opposing, will the gas will expand? No. If this external pressure is constant, P external, if it is constant, what it will happen? This gas will be expand. If this gas expand, if it gas want to be expand means P external should become constant. ఆ P external ఎప్పుడైతే కాన్స్టెంట్ అవుతుందో అప్పుడే మాత్రమే గ్యాస్ ఎక్స్పాండ్ అవుతుంది కదా. దెన్ వర్క్ డన్ ఈజ్ ఈక్వల్ టు మైనస్ P external dV. If suppose P is constant means అంటే P అనేది జీరో అయిపోతే వర్క్ డన్ వాట్ ఇట్ విల్ హ్యాపెన్? వర్క్ డన్ విల్ బికమ్ జీరో. If work done, if it is 0, then dq what it will happen? Dq will also will become 0. Why? According to the FLTD. According to the FLTD, dq is equal to minus dw. If the dw is 0, dq is 0. If dq is 0, if dq is 0, du is 0 and dh is also 0. Why? According to the FLTD, dq at constant volume, du, dq at constant pressure, dh. See, means if in the free expansion dq, du, dh, all the thermodynamic parameters are state function parameters are constant. I mean, like, sorry, not state function parameters. Now these are the parameters, it has become constant. dw is equal to 0, dq is equal to 0, internal energy is equal to 0, enthalpy is equal to 0. Done? I hope it is clear. I hope it is clear. Now, can I give one question? Can I give a question? Can I give a question based on the concept whatever we have studied now? Reversible, expansion, irreversible, expansion, compression, formulas and free expansion now we are. Now JEE means April 4, 2025 question. Now I was giving, now see, the question is 1 mole of an ideal gas, 1 mole of an ideal gas expands, 1 mole of ideal gas expands isothermally, 1 mole of ideal gas expands isothermally and reversibly from 10 decimeter cube to 20 decimeter cube at 300 Kelvin. At 300 Kelvin. Calculate delta U, Q and work done. Now R is equal to 8.3 joule per Kelvin mole. Now they have given log 2 is equal to log 2 is equal to 0.30, log 3 is equal to 0.48, ln 10 is equal to 2.3 they have given. Now what is the answer? What is the delta U, what is the Q and what is the W? Now say me the answer. Say me the answer. What is the answer? Delta U, delta is asking internal energy, heat and work. Why this much time you are taking? Very simple, we can solve, right? Are you trying or not? Okay, okay, fine, fine, you can try. Work is 1718 joules. Sign, Pranit, sign, it is negative or positive? So isothermal process, internal energy 0. Good. Vaishnavi, good. Pranit, good. Negative, right? Now, so it is a isothermal process, right? Internal energy is 0. Sign will play very crucial role. You have to be very careful with the sign. Okay? Work with sign you have to say me. With sign, negative. So work done in the reversible process will be equal to minus 2.303. N is 1, R is 8.33 they have given, and the temperature they have given 300 Kelvin, and log from where to where it is expanding 10, 20 to 10. So log 10 will be 1. So log 10 will be 1. If you multiply this work done in the reversible, you will get it as approx how much? Negative 171 joules. We know according to the FLTD at a constant temperature, work done negative reversible will be equal to the Q, right? So whatever may be the work done you got, that it will be the Q will be positive. So plus 715 joules. Yes. Good. Now this is the answer. And this is the internal energy will be 0. Now same question, April 3, 2025 question they asked. Same question. See, simple. Actually, if I was given the option, easily you can do. Because just to have some idea, just she is Subhana from the junior NEET. Subhana from now next. Right. Next one. Now same question in the April shift of NEET question also I will give same NEET question. The same this year in the 2025 the same NEET question they asked, but they have not given this one, internal energy they have not given. They just asked the heat and work they asked, but we know isothermal process internal energy is constant, so 0, no problem. Next one, work done graphs. Now we are going to see. My dear friends, this work done graphs, based on these graphs also, this year they asked the question. Now, how they asked? Now see, work done graphs. work done in isothermal expansion. Now I was explaining on the basis of expansion. Graph is on the basis of expansion. Now first, work done isothermal expansion means volume will be increases or decreases. In the expansion, volume will be increases or decreases. Volume will be increases or decreases in the expansion. Volume will be increases, right? So in the volume will be increases means now I was expanding the gas through reversible. Through the reversible, I was expanding the gas. As I was expanding the gas through the reversibly, we know reversibly will get the graph in this manner, rectangular hyperbola. Why? According to the isothermal process, P is inversely proportional to the V according to the Boyle's law. Means P is inversely proportional to the 1 by V. Means here ఇక్కడ రివర్సబుల్ ప్రాసెస్లో నేను ఒకవేళ వర్క్ డన్ చేస్తే నాకు గ్రాఫ్ ఎలా వస్తుంది? ఇలా వస్తుంది గ్రాఫ్, రైట్? వెన్ ఐ వాస్ గెటింగ్ ద గ్రాఫ్ ఇన్ దిస్ మేనర్, ఏరియా అండర్ ద కర్వ్ విల్ గివ్ యూ ద వర్క్ డన్ కదా. ఏరియా అండర్ ద కర్వ్ విల్ గివ్ ద వర్క్ డన్. అంటే ఇదే కదా ఏరియా అండర్ ద కర్వ్ ఫర్ ద దేనికి ఇది? దిస్ గ్రాఫ్ ఈస్ ప్యూర్లీ ఫర్ ద దేనికి? రివర్సబుల్ ప్రాసెస్ కా ఇర్రివర్సబుల్ ప్రాసెస్ కా? వర్క్ వైట్ షేడ్ వన్. ఇప్పుడు వాల్యూమ్ పెరుగుతున్న కొద్దీ ప్రెషర్ తగ్గుతుంటది కదా. లెట్ సపోజ్ ఇది ఇక్కడ 10 atm, ఎక్కడికైతే దాని వాల్యూమ్ పెరిగిపోయిందో దాని ఇక్కడికి వచ్చేసి 2 atm అనుకుందాం. నౌ వైట్ వన్ వర్క్ డన్ ఈజ్ అ రివర్సబుల్ వన్. ఇప్పుడు సేమ్ పీవీ గ్రాఫ్, I was expanding the gas through the irreversible. ఇర్రివర్సబుల్ అంటే ఏంది? ఇక్కడ చూడండి అమ్మా, క్లియర్గా వినండి. కొంచెం మీకు కన్ఫ్యూజ్గా అనిపిస్తుంది కానీ క్లియర్గా ఎక్స్ప్లెయిన్ చేస్తాను నేను. నౌ దిస్ ఈజ్ అ వన్ గ్యాస్, ఓకేనా? ఇప్పుడు ఈ గ్యాస్ దీని పి ఎక్స్టర్నల్ 10 atm ఉంది, ఓకేనా? 10 atm. ఇప్పుడు ఈ పి ఎక్స్టర్నల్ ప్రెషర్ని నేను ఒకటేసారి తగ్గిస్తే పిస్టన్ వెరీ ఫాస్ట్గా చేంజ్ అవుతుంది కదా. 10 atm నుంచి 2 atmకి తీసుకొచ్చిన. ఇప్పుడు ఇక్కడ ఈ పిస్టన్ది ప్రెషర్ పి ఎక్స్టర్నల్ 10 atm ఉంది. ఈ 10 atm ప్రెషర్ సడన్గా నేను 2 atmకి తీసుకొస్తే దాని వాల్యూమ్ ఏమైపోతుంది? వెరీ ఫాస్ట్గా సడన్గా ఇంక్రీజ్ అయిపోతుంది కదా వాల్యూమ్. అంటే ఇర్రివర్సబుల్ ప్రాసెస్లో ఇక్కడ 10 atm దగ్గర ఉన్న పి ఎక్స్టర్నల్ని సడన్గా నేను 2 atm దగ్గరికి పట్టుకొచ్చిన. 2 atm దగ్గరికి తీసుకొస్తే దాని వాల్యూమ్ ఏమైపోయింది? సడన్గా ఇంక్రీజ్ అయిపోయింది. మరి ఇప్పుడు ఇదే కదా ఇర్రివర్సబుల్ ప్రాసెస్ వర్క్ డన్. ఇదే కదా ఇర్రివర్సబుల్ ప్రాసెస్ వర్క్ డన్. ఎల్లో షేడ్ ఈజ్ అ ఇర్రివర్సబుల్ ప్రాసెస్ వర్క్ డన్. మరి వర్క్ డన్ ఇన్ ద ఐసోథర్మల్ ఎక్స్పాన్షన్ లో రివర్సబుల్ వర్క్ డన్ ఎక్కువైందా, ఇర్రివర్సబుల్ వర్క్ డన్ ఎక్కువైందా? అది చెప్పండి. ఇప్పుడు నేను ఒక ఐసోథర్మల్ ప్రాసెస్లో ఒక గ్యాస్ని 2 ప్రాసెస్లలో ఎక్స్పాన్షన్ చేసిన. ఒకటి రివర్సబుల్ నుంచి చేసిన, ఒకటి ఇర్రివర్సబుల్ చేసిన. మరి ఇప్పుడు రివర్సబుల్ నుంచి ఇర్రివర్సబుల్ నుంచి నేను చేసినప్పుడు నాకు వర్క్ డన్ దేనికి ఎక్కువ వచ్చింది? మోడ్ ఆఫ్ వర్క్ డన్ రివర్సబుల్ విల్ బి గ్రేటర్ దెన్ మోడ్ ఆఫ్ వర్క్ డన్ ఇర్రివర్సబుల్ కదా. అంటే రివర్సబుల్ వర్క్ డన్ ఈస్ హయ్యర్ దాన్ ద ఇర్రివర్సబుల్. ఏది? ఎక్స్పాన్షన్లో. ఇది ఎక్స్పాన్షన్కి గ్రాఫ్. మరి సేమ్ థింగ్ కంప్రెషన్ గ్రాఫ్కి చూస్తాం. కంప్రెషన్ వర్క్ డన్ ఇన్ ఐసోథర్మల్ కంప్రెషన్, ఐసోథర్మల్ కంప్రెషన్. ఇప్పుడు ఒకవేళ ఐసోథర్మల్ కంప్రెషన్ చేస్తే నాకు ఎట్లా గ్రాఫ్ వస్తుందో చూసాం. ఇది ప్రెషర్, ఇది వాల్యూమ్ కదా. నౌ ఫస్ట్ కంప్రెషన్ కూడా రివర్సబుల్ ఒకటి, ఇర్రివర్సబుల్ నుంచి చేస్తాం. ఫస్ట్ కంప్రెషన్ అంటే వాల్యూమ్ తగ్గుతుంటుంది కదా, వాల్యూమ్ తగ్గుతున్నా కొద్దీ ఏమైపోతుంది, ప్రెషర్ పెరుగుతుంది. సేమ్ మళ్ళా రివర్సబుల్కి ఎక్స్పాన్షన్కి కంప్రెషన్కి సేమ్ గ్రాఫే కదా వచ్చింది. అదే కదా ఏరియా అండర్ ద కర్వ్, ఇవే కదా వచ్చింది. ఇక్కడ కూడా అదే కదా వచ్చింది, అదే కర్వ్ వచ్చింది. ఇక్కడ కూడా అదే కర్వ్ వచ్చింది. సరే అట్లా కన్ఫ్యూజ్ అయితే చూడండి, తీసుకుందాం. అదే గ్రాఫ్ వచ్చింది కదా. కంప్రెషన్లో అయినా ఎక్స్పాన్షన్లో అయినా మనకి రివర్సబుల్ ప్రాసెస్లో ఏదైతే వర్క్ చేస్తున్నామో కంప్రెషన్కి ఎక్స్పాన్షన్కి సేమ్ గ్రాఫ్ వచ్చింది రివర్సబుల్లో. అదే ఒకవేళ ఇర్రివర్సబుల్లో చేస్తా. ఇర్రివర్సబుల్లో చేస్తే ఇర్రివర్సబుల్లో ఏంటి అంటే ఇప్పుడు చూడండి, ఇప్పుడు ఈ ప్రెషర్ పి ఎక్స్టర్నల్ 2 ATM అనుకుందాం. నేను సడన్గా దీని ప్రెషర్ని పెంచుతా, అంటే ఒక 100 kgs ఆఫ్ ద మాస్ని దీంట్లో డ్రాప్ చేస్తే ఇప్పుడు దాని ప్రెషర్ ఎంత అయిపోయింది, 10 ATM అయిపోయింది. అంటే ఇక్కడ ఏమైపోయింది, నేను 2 ATM దగ్గర ఉండాల్సిన మన ఒక సిస్టమ్ యొక్క ప్రెషర్ని 10 ATMకి ఒక్కటేసారి తీసుకొస్తే దాని వాల్యూమ్ ఏమైపోయింది, సడన్గా చేంజ్ అయిపోయింది కదా, సడన్గా చేంజ్ అయిపోయింది. అంటే ఇప్పుడు 2 ATM దగ్గర ఉండాల్సిన ప్రెషర్ని నేను ఎక్కడికి తీసుకొచ్చిన, 10 ATM ప్రెషర్ దగ్గరికి తీసుకొచ్చిన. 10 ATM దగ్గర ప్రెషర్ తీసుకురాగానే ఇప్పుడు లెట్ సపోజ్ ఇది 50 ml అనుకుందాం, ఇది ఎంత 10 ml అనుకుందాం. 50 ml దగ్గర ఉండాల్సిన నా ఒక సిస్టమ్ యొక్క వాల్యూము ఎక్కడికి వచ్చేసింది, 10కి వచ్చేసింది. 10కి వచ్చేసింది కదా. అంటే ఇప్పుడు ఇక్కడి నుంచి ఇక్కడ వరకు కదా వర్క్ డన్ చేసింది. మరి ఇదే కదా దాని ఏరియా అండర్ ద కర్వ్. ఇర్రివర్సబుల్ ప్రాసెస్లో దాని ఏరియా ఎంత, ఇదే కదా. మరి వర్క్ డన్ ఇన్ కంప్రెషన్లో రివర్సబుల్ వర్క్ డన్ ఎక్కువ జరిగిందా, ఇర్రివర్సబుల్ వర్క్ డన్ ఎక్కువ జరిగిందా? రివర్సబుల్ వర్క్ డన్ ఎక్కువ జరిగిందా, ఇర్రివర్సబుల్ వర్క్ డన్ ఎక్కువ జరిగిందా? వర్క్ డన్ ఇర్రివర్సబుల్ కదా. అంటే వర్క్ డన్ ఇన్ ఇర్రివర్సబుల్ ఈజ్ గ్రేటర్ దాన్ వర్క్ డన్ రివర్సబుల్. వర్క్ డన్ ఇర్రివర్సబుల్ ఈజ్ గ్రేటర్ దాన్ వర్క్ డన్ రివర్సబుల్. క్లియర్ అయిపోయిందా? క్లియర్ కదా. వర్క్ డన్లో ఏ గ్రాఫ్లో వర్క్ డన్ ఎక్కువ, ఏ గ్రాఫ్లో వర్క్ డన్ తక్కువ. సేమ్ ఇదే కాన్సెప్ట్ మీద 2025 ఏప్రిల్ షిఫ్టా, ఏప్రిల్ టు 2025 షిఫ్ట్, ఏప్రిల్ టు 2025 షిఫ్ట్లో ఒక క్వశ్చన్ అడిగిండు. ఏం క్వశ్చన్ అడిగిండు అంటే నేను ఆ క్వశ్చన్ రాస్తా చూడండి. రైట్, నేను ఆ క్వశ్చన్ మీకు పెడుతున్నా. జస్ట్ వెయిట్, లెట్ మీ సర్చ్ దట్ క్వశ్చన్. Wait, let me search the question. Now better I will write. క్వశ్చన్ ఏం అడిగిండంటే అరేంజ్ ద ఫాలోయింగ్ magnitude of work done by the system, magnitude of work done by the system and work done on the system at a constant temperature. Okay na, at a constant temperature. ఆప్షన్ ఏ ఇచ్చినాడు, mod of work done reversible for expansion in infinite stage. B option they have given work done irreversible for expansion in a single step. C, mod of work done reversible for compression in a infinite stage. D, work done irreversible for compression in a single step. Okay na? Now this is the question they have given. He is asking the magnitude of work done. దేంట్లో వర్క్ డన్ ఎక్కువ, ఆర్డర్ ఫ్రమ్ హయ్యర్ టు లోవర్. He is asking magnitude of work done from higher to lower. దేంట్లో వర్క్ డన్ ఎక్కువ జరుగుతుంది, హయ్యర్ టు లోవర్ అడుగుతున్నాడు. ఫ్రమ్ హయ్యర్ టు లోవర్ ఈజ్ ఆస్కింగ్. Magnitude of work done from higher to lower. Options. You say it in the options. Like A greater than B greater than C, లేకపోతే you say it in the form of options. You say it in the form of the option. Okay, D. Then after that, and B is least. Okay. D is highest, B is least. Okay, fine. Then after, okay. I will give the options. Now you say me the answer for it. So according to the given concept, so the option A they have given, it is A greater than B greater than C greater than D. B they have given D greater than C is equal to A greater than B. So C they have given C is equal to A greater than D greater than B. So D they have given A greater than C greater than B greater than D. So what is the answer? Option B. We know finite step means reversible, single step means irreversible. So just now we have seen work done in the reversible expansion and work done in the reversible compression will be same. Now work done in the irreversible is less and work done in the compression case it is high. So same question they have asked in the April to 2025. This they have asked in the April to 2025. Same question. And the NEET second question they asked on the basis of entropy. Actually NEET also we got the two questions. One is just now we have discussed it, right? Work done formula, and the next concept question on the entropy. Now for this one we have got. So the B is yes, sir. I hope it is clear. This type of the simple questions only they are asking in the JEE as well as NEET. Just formula based question. See the data of the question and solve. Now, next. Next question we'll see. Next concept will go. After the completion of the concept, then by combining all the concept, I will ask the one question. Now, up to now, we have seen the work done formulas in the isothermal, reversible and the irreversible we have seen. Now we are in the isothermal. Now we are going to see the work done formulas in the adiabatic one. Adiabatic process. Now we are going to see the formulas on the basis of adiabatic process. Right? Now in the adiabatic process, here the one very beautiful statement based question they will ask you. What is the statement based question they will ask you? Adiabatic expansion, what will take place? Adiabatic compression. Adiabatic expansion, what it will take place? Adiabatic compression, what it will take place? Now say me the answer. If you know the answer, say me. If not, I will explain. Adiabatic expansion, what it will take place? Adiabatic compression, what it will take place? In adiabatic process, if the gas is expanding, what it will take place? Cooling will take place or heating will take place? In the adiabatic process, if the gas is expanding, cooling will take place or heating will take place, I am asking. Adiabatic expansion, cooling will take place. Yes, good Subhana, good. Why? Because according to the FLTD, we know internal energy will be equal to Q plus W, right? Now, when the work is happening, gas is expanding, here the Q is constant, right? Then internal energy will be equal to W. Now, W is equal to internal energy formula NCV T2 minus T1. Now, internal energy formula, molar heat capacity, when we have studied, I explained very clearly about this formula. Now, you can see internal energy is equal to NCV delta T. This is the formula we are having. So, here the T2 minus T1. Now, in the final, when the gas is expanding, what it will happen? When the gas is expanding, final temperature will be decreased. Final temperature will be less. In the expansion, final temperature will be less than initial temperature. If the final temperature is less than the initial temperature, then what it will happen? Cooling will take place. Example, flattened tire. See, when the tire it is rotating, now whatever may be the gas it is in the tire, what it will happen? Now it is having the higher temperature now. When this tire has become burst, what it will happen? Whatever may be the air it is in the tire, it will be comes to the surrounding, because initially this gas is having, let's suppose, 30 degrees Celsius. Surrounding temperature is 25 degrees centigrade, means Means whatever may be the gas, when this tire has been busted, the gas temperature is 30. When it has comes to the surrounding, now surrounding temperature is 25, means final temperature is less, right? Final temperature is less means obviously cooling will take place. So one statement based question they will ask, it is important, you have to be remember. In the adiabatic expansion, what it will happen? Cooling will take place. In adiabatic compression, what it will take place? Heating will take place. Why? Final temperature will be greater than initial temperature. Clear? I hope it is clear. I hope it is clear. Okay, na? Adiabatic expansion, cooling takes place. Adiabatic compression, heating takes place. Yes, done. Now the work done formula for the adiabatic, work done formula for the work done of adiabatic expansion, adiabatic reversible expansion and compression of ideal gas. Done. Now according to the FLTD, we know du is equal to dw. Now dw is equal to ncv dt. If it is for the 1 mole, n will become 1, then it will become cv dt. Now we know cp minus cv is equal to nr, right? Now for this one, for our mathematical calculation purpose, I was dividing it by the cv. If I was divided by the cv, then it will become cp by cv minus 1 is equal to nr by cv. Now cp by cv will be the gamma, we know, cp by cv. Then can I write gamma minus 1 is equal to nr by cv, nr by cv. If I send this will play very crucial role. Now if I send cv to the left hand side, cv is equal to nr by gamma minus 1, nr by gamma minus 1. Now this is a one cv we got. Now this cv if you substitute here, now work done formula dv is equal to nr gamma minus 1 dt, nr gamma minus 1 dt. Now for overall change, if you do the integration, because nr gamma minus 1 is constant, then work done in the reversible will be equal to nr gamma minus 1 T2 minus T1. Now you see adiabatic work done in the reversible process. Now we got the different formula. Adiabatic reversible work done different, we got it. Isothermal reversible we got the different formula, and irreversible we got the different formula. See, done. Next after that, one very important, this is very important for the, either for if you are preparing for the JEE, either you are preparing for the NEET, either if you are preparing for any state entrance exam. This is very important. Based on this formula, we are going to derive one general expression which is helpful to get the second law of thermodynamics. ఇప్పుడు నేను ఏదైతే ఫార్ములాస్ డిరైవ్ చేస్తున్నానో ఆ ఫార్ములాస్ ఓన్లీ అప్లికబుల్ ఫర్ ద అడియాబాటిక్ రివర్సబుల్ ప్రాసెస్ కి మాత్రమే అప్లికబుల్. ఈ ఫార్ములాస్ ఏవైతే నేను ఇప్పుడు డిరైవ్ చేస్తున్నానో అది స్టేట్మెంట్ బేస్డ్ క్వశ్చన్ గా ఒకసారి ఎగ్జామ్ లో అడిగాడు. ఏం అడిగాడంటే పివి పవర్ గామా ఈస్ అప్లికబుల్ ఫర్ ద isothermal process, adiabatic process in that adiabatic process only for the reversible, in the adiabatic process only for the irreversible, or only for, or it will be applicable for the both. ఇట్లాంటి స్టేట్మెంట్ బేస్డ్ క్వశ్చన్ అడిగినాడు కాబట్టి పీవీ పవర్ గామా విల్ బి అప్లికబుల్ ఓన్లీ ఫర్ ద అడియాబాటిక్ రివర్సబుల్ ప్రాసెస్. అది ఎలా అంటే నేను డెరివేషన్ ఏం చెప్తలేను, డెరివేషన్ మనకి అవసరం లేదు, ఇట్ ఈస్ నాట్ ఎట్ ఆల్ రిక్వైర్డ్. బట్ ద జనరల్ ఫార్ములాస్ యూ హ్యావ్ టు రిమెంబర్ దట్ ఇట్ ఈస్ అడియాబాటిక్ రివర్సబుల్ ఓన్లీ, ఇట్ ఈస్ అప్లికబుల్. ఆ ఫార్ములాస్ ఎట్లా వచ్చినాయి డెరివేషన్ నేను చెప్తలేను, I was not deriving the derivation, it is not at all required, just you remember. One is the general formulas, you have to remember the general formulas, the general formulas that we are going to see, that is a general expression. From this general expression we know dW is equal to du. Now du is equal to minus P external dV. Now du is equal to CV dt is equal to minus P external dV. Now for the ideal gas, we know P external will be equal to the P gas. Now from this, by doing this integration, on integration of this all, we get the formula. By doing the integration we get the formula, that is first formula we got it, it is TV power gamma minus 1 is equal to constant. This is the one formula we got. Next, PV power gamma is equal to constant. This is very very important point, you have to remember. Applicable only for which one? Reversible adiabatic, for adiabatic reversible only. This is the one very 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 key point you have to remember. Directly they will ask you. Okay, next formula we are having P1 minus gamma, T gamma is equal to constant. Next, same formula, T2 by T1 is equal to P1 by P2 first law. I am your student from Nizam College. My dear Shravan, I was not teacher in the Nizam College. Now maybe you are my friend, I think so, Shravan. Right, now these are the formulas that we have to remember for the only for reversible, which one? Reversible process of adiabatic. Done. Next one, and the next one we are going to see adiabatic irreversible expansion or compression of ideal gas. Done. Now the formula we will get for this one, same, dW is equal to du, dW is equal to CV dt for n is equal to 1. Done. Now next formula we are having CV is equal to NR gamma minus 1. Now dW is equal to NR gamma minus 1 dt. Now if I do the integration, overall integration, if I do dW is equal to nr gamma minus 1 dt, then it will become work done irreversible will be equal to 1 by gamma minus 1 nr. Okay, if you are getting confusion, better we'll do like this, T1 to T2. Now this one will become nr gamma minus 1 T2 minus T1. If I send the nr to the left hand side or nr to the inside, now what I will get, work done in the reversible will be equal to 1 by gamma minus 1 P2 V2 minus P1 V1. Now this is a one formula we got for the work done in the reversible. This is the one formula we will get, and another formula also we will having for the work done irreversible. Work done irreversible, we are having the one formula, that it is, we know in the adiabatic process Q is equal to 0, then internal energy will be equal to W, then internal energy will be equal to W means NCV T2 minus T1, this is for the internal energy formula, minus P external V2 minus V1 we are having for the work done in a irreversible process, then minus P external nRT2 by P2 minus nRT1 by P1 is equal to NCV T2. This is also one beautiful formula if you remember for the work done in the adiabatic irreversible process. This is also one beautiful formula we are having. Okay, now I will write all the 4 work done formulas of the first law of thermodynamics. All the formulas I will write. First one, work done formula, so that it will be remember for you. Work done is equal to minus V1 to V2 P external dV. Now work done reversible isothermal, that it will be minus 2.303 nRT log V2 by V1 base 10, right? Now work done irreversible isothermal. Can anyone say me the formula of this one? Can anyone say me the formula of this one? Work done irreversible isothermal, that it will be equal to minus nRT 1 by P2 by P1. Now this is a work done isothermal reversible. Now this is work done irreversible isotherm formula. Next one, work done in the adiabatic, work done reversible in adiabatic will be equal to nr gamma minus 1 T2 minus T1. Now work done irreversible adiabatic will be equal to what is the formula? NCV T2 minus T1 is equal to minus P external V2 minus V1. Now these are the work done formulas we have to remember. So whatever may be the work done they may ask, according to the given data of the question we have to use this work done formulas. I hope it is clear. This many work done formulas we are having. Now to complete the first law only, it has taken the 4 hours. 7 o'clock we have started, right? First law itself it has taken the 4 hours. Now we'll do the questions. We'll do the questions. Now, right. Now, the question I was giving is now, question I will give you. Now you have to say me the answer. Uh, Now the question given is 500 joule of energy. My dear friends, are you there? Any the one who is in the live, just say me hi. 500 joules of energy is transferred as uh, as heat to 0.5 mole of argon gas at 298 Kelvin and 1 atm. The final temperature and the change in internal energy respectively is asking. Change in internal energy respectively is asking. Okay, now R is equal to 8.3 kilojoule per mole. Clear? My dear friend Dexter, you can focus on the class. Now is asking the final temperature and the change in internal energy. The question he has given 500 joules of energy is transferred as a heat to the 0.5 mole of argon gas at 298 Kelvin and 1 atm pressure. Now the final temperature and the change in internal energy respectively are. Now try. Are you trying? Are you trying this question? Yes sir. Okay, done. Try. Final temperature 378. No, once you cross check, ఫైనల్ టెంపరేచర్ 378 కాదు అనుకుంటా, ఒకసారి క్రాస్ చెక్ చేసుకోమా. నో వైష్ణవి, వన్స్ యూ క్రాస్ చెక్ యువర్ ఫైనల్ టెంపరేచర్ అది కాదు, 378 కాదు. బట్ ద ఫైనల్ టెంపరేచర్ ఇస్ నాట్ 378 వస్తుందా? అవునా? ఫైనల్ టెంపరేచర్ 378 కాదు, సార్ క్రాస్ చెక్ చేయి. 378 it is getting a okay, fine. Okay, 378 378 వస్తుందా? ఓకే ఫైన్. 378 you got it for the which one you got? Final temperature you got. Initial temperature, సరే ఇనిషియల్. నెక్స్ట్ ఏం అడుగుతున్నాడు? ఇంటర్నల్ ఎనర్జీ అడుగుతున్నాడు కదా. ఏం అడుగుతున్నాడు? ఫైనల్ టెంపరేచర్ అండ్ చేంజ్ ఇన్ ఇంటర్నల్ ఎనర్జీ ఎంత? ఇంటర్నల్ ఎనర్జీ ఎంత? ఇంటర్నల్ ఎనర్జీ 500 joules. Energy is transferred as heat to the yes, అంతే. రైట్ 500. గుడ్ 500 అంతే కరెక్ట్. సో ఆన్సర్ ఫైనల్ టెంపరేచర్ ఇస్ 378 అండ్ internal energy is 500. Good. Next question we'll complete the first law of thermodynamics questions. We'll finish the first law of thermodynamics questions and then after that we'll start the second law. One interesting question they gave. What is the one interesting question he has given means correct option for free expansion. Correct option for free expansion of an ideal gas. Option A, Q is equal to 0, delta T is not equal to 0, W is equal to 0. B, Q is equal to 0, delta T less than 0, W is equal to 0. W is not equal to 0. C, Q is not equal to 0, delta T is equal to 0, W is equal to 0. D, Q is equal to 0, delta T is equal to 0, W is equal to 0. Now what is the answer? What is the answer? Option D. Now we know, right? If Q is equal to 0, W will be equal to 0. Q will be equal to 0, W will be equal to 0. Now internal energy will be equal to the dW. If the dW 0, internal energy will be 0. Internal energy is equal to NCV delta T. If internal energy 0, temperature will be 0. So Q0, delta T 0, W 0. Right. This is a very simple question only. Next one type of the question they have given. Question they have given, it is when methane undergoes combustion. Methane undergoes combustion in a system A and B. Methane undergoes combustion in system A and B respectively. Okay. Now A is adiabatic. A is adiabatic system. B is diathermic system. B is diathermic container. Okay na? This is A, this is B. So when the combustion it is undergoing, methane it is undergoing combustion, what it will be happened? A, system A and system B. Temperature rises, temperature same. Okay, this is option A. Now option B. Now let me choose this. This is option A. Now option B they have given system A, temperature falls, system B, temperature rise. Now C, system A, system B, temperature falls, temperature same. Next D, system A, system B, temperature same, temperature rise. Now say me the answer. No. What is the answer? Now what is the answer for this one? Oh, someone is asking some question. D, I think, sir. D. Once you cross check once again. Once again. Here the first one. Now the methane gas is undergoing in the A and B. It is undergoing in the container A and B. Methane gas is undergoing combustion in the one is in the A, and one is in the B. Logic world, what is the reply? FT graph area gives change in momentum or work done. I mean, like what? What is the doubt you are having? Force versus temperature you are asking, or FT? Can you elaborate your question? Can you FT something your okay? Now D is not the answer. Once you cross check, D is not the answer. D is not the answer once you cross check. Once you cross check, you will get once you see answer. See Rana, methane gas, if it is undergoing in the adiabatic system, okay, in the adiabatic, which will not exchange in the adiabatic, and which will exchange in the diathermic. Adiabatic, which will not exchange? No. See here, if it is A and B, these walls are adiabatic. If in this case, if the methane is undergoing the combustion, if it is undergoing the combustion, whatever may be the heat it is coming from this reaction, heat will be increased in this one, right? If the heat increase means temperature will be raised here in the A. Temperature will be raised because diathermic wall, adiabatic wall will not allow the temperature to go outside. So whatever may be the heat it is coming from this methane, it will be present in the A container only. So in the system A, temperature will be raised, temperature will be increases, right? Diathermic wall will exchange the heat, means whatever may be the heat it is coming from this combustion, heat it will go out, means whatever may be the temperature it is having in the starting, temperature will be remain same. So the option A is correct. So why you are getting confusion? See here in the combustion it is undergoing. Combustion undergoing means adiabatic wall will not allow the heat. అడియాబాటిక్ హీట్ ని అలో చేయదు కాబట్టి అక్కడి నుంచి ప్రొడ్యూస్ అవుతున్న హీట్ వల్ల టెంపరేచర్ రైజ్ అవుతుంది. ఇప్పుడు డయాథర్మిక్ వాల్ అనేది టెంపరేచర్ ని బయటికి పంపిస్తుంది కాబట్టి సో టెంపరేచర్ అనేది కాన్స్టెంట్, సో రిమైన్ సేమ్. అది అదే అడుగుతున్నాడు, టెంపరేచర్ రేజెస్ అని. ఓకే, రైట్. ఓకే, ఫైన్. నెక్స్ట్ ఒక క్వశ్చన్, బ్యూటిఫుల్ క్వశ్చన్. ఇది కూడా ఏం అడుగుతున్నాడు అంటే, వెన్ 2 liters of ideal gas expands, my dear logical world, what the question you have asked, I don't know, just you are asking me to reply. Now when 2 liters of ideal gas expands isothermally into vacuum to a total volume of 6 liters, the change in internal energy is in joules, nearest integer. Nearest integer. What is the answer? What is the answer? What is the answer for this question? Wow, good, good, Pranit, good. అంతే చూడు, అన్నెసెసరీ డేటా అంతా డంప్ చేసి ఒక చిన్న లాజిక్ ఇచ్చినాడు, వాక్యూమ్ అని. Vacuum in the sense it is a free expansion. If the gas is expanding freely, then pressure is constant. External pressure is constant means work is constant, pressure constant. Work constant ఏంటంటే internal energy constant, so it is zero. చిన్న లాజిక్ అంతే, చిన్న లాజిక్. అన్నెసెసరీ డేటా అంతా డంప్ చేసి ఒక చిన్న లాజిక్ ఇచ్చేసినాడు క్వశ్చన్లో. ఆ చిన్న లాజిక్ ఇఫ్ వి ఐడెంటిఫైడ్, నో నీడ్ ఆఫ్ క్యాలిక్యులేటింగ్ ఎనీథింగ్. నెక్స్ట్ next type of the question. Next question, where are you? Next question we are having 1 mole of ideal gas, 1 mole of ideal gas is allowed to expand reversibly and adiabatically from a temperature 27 degrees Celsius. The work done is 3 kilojoule per mole. The final temperature of the gas is dash Kelvin. -27 degrees. The work done is 3 kilojoule. Now CV is equal to 20 joule per mole Kelvin. Nearest integer. Nearest integer. Shh. 177 prox. No, it's not 177. Once you cross check your calculation part, good. 150. See, adiabatically is saying means internal energy is equal to what? NCV delta T. NCV delta T will be equal to the work done, right? Now N they have given, CV they have given. What is asking? Change in internal energy is asking. Change in internal energy, and work done they have given in the 3 kilojoule per mole, but is asking in Kelvin. Kilojoule they have given, convert it into the Kelvin. No. My work done, this is W, right? Work done they have given it as a 3 kilojoule. Work done how much they have given? 3 kilojoule they have given. 3 kilojoule, but asking unit in the Kelvin. So convert this kilojoule into joule. Then it will become what? Minus 300 N. N is 1 mole, right? CV 20. Final temperature is asking. Initial temperature how much they have given? 300 will be equal to work done, right? Work done in the expansion will be equal to minus 3000. That if you do, you will get the answer. This if you do the calculation, you will get the answer. Expansion is saying, right? Expansion case, work done will be the negative. Then if you calculate, you will get the T2. T2 you will get approximately 150 Kelvin. Now next one formula I will now almost on all the basis of the formulas we have done the question. Now last formula which we have not used up to now, on that basis I was giving the one question. Be carefully, don't be in hurry, see the data of the question and solve. Okay, the question is an ideal gas CV and ideal gas CV is equal to 5/2 R is expanded adiabatically against constant pressure. So you got right. If I was using the constant pressure means it is related to which process? Reversible or irreversible? Of 1 atm until it doubles in volume. If the initial temperature and pressure, is 298 Kelvin and 5 atm respectively, then the final temperature in Kelvin. Now see me the answer. One very interesting question this is. In the question itself, which formula you have to use? Which formula you have to use? They have given. An ideal gas CV is equal to 5/2 R is expanded my dear Raghav, for which question you are saying it is a wrong? Which question solution is wrong? Now, for which formula we have to use for this question? Which formula we have to use for this question? Which formula we have to use for this question? Which question you are saying, my dear friend Raghav? Which is 6? What is the 6 you are saying? Answer. My dear friends, are you there? Anyone? So constant pressure. Against constant pressure they have given. Adiabatic. Adiabatically constant pressure if they have given means what is the formula we have to use? Adiabatic constant relation. No, array, why you are getting confusion? I said you right. Constant pressure against constant pressure means against constant external pressure. Against constant external pressure means you have to use the, this is the formula, right? Irreversible process, right? Constant against the constant, irreversible. Then you have to use this formula. Use this formula, whatever the data they have given. This is the first question, this is the second question, and this is the third question. For the third, this is the third question, and this is the fourth question. Fourth question, this is 0. My dear friend, here it is a vacuum. When the 2 liter of ideal gas expand isothermally in the vacuum, vacuum if they have given means vacuum in the sense it is expand against the constant pressure. In the next question we are having, this is the formula T2 you will get. For this formula, now I will write the formula, try to according to the given data what they have given, just you add it and send me the answer. Minus P external V2 minus V1. Now this is a question. Yes, that is a formula. NCV T2 minus T1 will be equal to minus P external V2 minus V1 you have to use. 273 Kelvin is the answer. Vaishnavi is saying the answer is 273 Kelvin. Okay. You can do. I will wait. Okay. You can do. But 273 Kelvin కాదమ్మా. వైష్ణవి the answer is not the 273 Kelvin, కానీ అప్రాక్స్ కి వచ్చినాం. ఒకసారి మళ్ళీ ఒకసారి ట్రై చేయి. అప్రాక్స్ యు కేమ్. Approx you came but not exact. Okay, fine. Are you trying or should I explain? Now volume already you have said until its volume doubles in volume. Doubles in volume means V2 will be equal to 2V1. Now nRT T2 P2 is equal to 2 nRT1 by P1. If you do, you'll get the answer. P1, how much they have given? Initial pressure 5 atm. Expansion is saying, right? Expansion P is 1 and P2 is 1. 274 you will get approx. Yes. Good. 274 you will get. Yes, 274. Right. Now, by this almost we have completed our first law of thermodynamics, but one very beautiful graphs it has been left that I will finish. Then after that we'll start. My dear friends, you will be with me, or shall I stop the up to first law of thermodynamics? Nothing is there. This is a formula, right? He has given. Now we know V2 will be equal to 2V1, but he is saying constant pressure of 1 atm until its volume until it doubles in volume. Until it doubles its volume is right. V2 will be equal to 2V1. We know the formula. Now V2 formula nR T2 by P2. Now V1 formula according to the ideal gas 2 is equal to nR T1 by P1. Then if you cross change, you will get the answer. Then P1 will be equal to the 5 and T1 will be equal to the 298 Kelvin. Now P2 will be equal to the, then if you substitute, you will get the answer. P2 is 5. P2 is, then if you substitute, you will get the answer. And CV they have given already. CV how much they have given? 5 by 2 R they have given. Final pressure will be the 5, initial to final. Okay. Now one last graph I will explain and I will finish the first law of thermodynamics. I will stop it here, and tomorrow second law of thermodynamics continue we will take. Okay, right? First law I will take it here, but last I will explain the graphs, and I will last one PV graphs are there that I will explain and I will close. No need. Better we'll take the second law tomorrow only, because we are not in that much mood also. Now last the PV graphs that we will I will explain. Now what is the PV graphs is, now this is a P versus V. Here if suppose if they have given the graph like this, now if suppose the graph if they have given in this manner, okay, now you have to say me the answers for the graph. This is 1, this is 2, and this is 3, and this is 4. Now what is the one graph for which process this one graph related? For the second graph will be related to which process? Third graph will be Now third graph will take third graph which and fourth one which. Now say me which process? First graph represent to the which process? First one is isobaric. Okay. Second one. Second one. Second one. Second graph represent for no. First is isobaric. First is isobaric. Second one is isothermal. Second is isothermal. Third is adiabatic. And fourth, easily we can say volume is constant, means isochoric. Isochoric. Second is isothermal. Right? Here, among these four process, which process will do more work? Among these four process, which process will do more work? Which process will do more work? Which process will do more work? And I will explain why the graph for the adiabatic we got it as less and why the graph for the isothermal we got it as high. Now, isobaric process will do the more work, right? Isobaric process will do the more work. Done? Now, why the graph we got for the isothermal and the adiabatic, why the graph it has came? Now I will explain. Listen. Isothermal process. We know isothermal process which is constant, temperature is constant, so the PV is constant. If the PV is constant, if you apply the differentiation UV, P and V, if you apply, now PdV plus VdP is equal to 0. Then VdP is equal to minus PdV. Then dP by dV is equal to minus P by V. Now, this is the slope, right? Now, here slope, what we got? P versus V. P versus V. Then we got dP by dV is equal to minus 1 P by V. Minus 1 P by V. Slope we got it as a minus 1. Now, this is for the isothermal. This is for the isothermal. Okay. Now, next. Adiabatic case if you see. Adiabatic case if you see. Now, adiabatic case, for the adiabatic reversible only I was explaining. Reversible process. PV power gamma is equal to constant. Right. Now, if you apply the differentiation UV, PV power PV gamma directly I was returning. Now, next, if the PV power gamma is equal to constant, now if I was, thank you Meena. Now, here PV power gamma is equal to constant. If I apply the differentiation UV, then what I will get? P gamma V power gamma minus 1 plus V power gamma dP is equal to 0. Then dP by dV will be equal to, directly I was writing, minus gamma into P V power gamma minus 1 minus gamma by V power gamma. Then this all gamma V power gamma will be get, sorry, not this one. Wait. Now, if I write direct, now if I interchange dP by dV, now dV somewhere, differentiation u power gamma dP, here dV, sorry, into dV. Now dP by dV is equal to minus gamma minus gamma into P into V power gamma minus 1 by V power gamma. If you do, now what you will get, dP by dV is equal to minus gamma P by V you will get. Now we know gamma value will be greater than 1. Gamma value will be greater than 1, right? Why? For the monoatomic gas, gamma value will be 1.6, diatomic gas 1.4 and the triatomic gas 1.3. Means if the gamma value is greater than 1 means minus this gamma values will be more negative than the 1, right? So that's the reason the slope we are getting it as a negative for the diatomic. I hope it is clear. I hope it is clear for the why the slope for the isothermal is higher and why the slope for the adiabatic it is more lower than the isothermal, because there the slope for the adiabatic it is a gamma value is greater than 1, right? So more negative means more. Now better I will stop the lecture here and will continue tomorrow with the which one, with the second law of thermodynamics. See, only for the first law of thermodynamics only it has taken almost 5 hours. Okay, second law of thermodynamics, tomorrow I will try to take the class earlier only. How much time it will take I too don't know, but earlier only I will try to take and I will intimate you in the respective groups, or I will post it in the Instagram, or I will give it the status, so that by that we can continue. Tomorrow we'll finish the thermodynamics, and the day after tomorrow which chapter I have to start? Based on your interest I will start. Which chapter? Chemical bonding can I start? Next, after completion of this one I will start the chemical bonding, because both these two chapters are very high weightage. After that with the one shot I will complete the chemical bonding also. Those two chapters are big. Okay, tomorrow we'll start the thermodynamics. Okay, my dear friends, equilibrium or CB. Chemical bonding will start. Chemical bonding will start because chemical bonding is a high weightage than the equilibrium. Okay, my dear friends, now in your holidays also you are spending very valuable time for the studies. I hope you will get the good academics and a good rank in your further your exams. Right, bye, see you. Good night, good night. Bye, bye, bye. Right.